Hello grade 12, welcome to my channel, and today siphethe ama-cry nice izinto ezikhala kahle. So let's see what was going on in this province for your trials in maths paper 2. So this is from Mpumalanga, and we're going to review it together to learn a few concepts together and also the skill of solving these past exam question papers. Let's quickly run into the instructions. It's always important to ensure that you read all instructions essentially and commit to memory these ones. So we're doing 2 decimal places, no less, no more. Okay. Otherwise, read the rest and essentially make sure you are clear about that. So let's start. So question 1 says, the table below shows the masses in kilograms, so the unit of measurement is given, of 15 randomly chosen weightlifters of a certain gymnasium. All right, there they are. Okay, now we're told here to calculate the mean mass. So this is going to be all calculator work. So let's quickly get to question 1. It's all calculator work. So what do we do here? We just simply go to mode on our calculator. The mode will take us to stats. We just choose the option that's written stats. Okay. Let me just see mode, and then stat is option 3 there. And then from there we go and choose, because this is univariate data, univariate data, meaning the variable is just x. So we're going to choose option 1 here, which is written 1 var, meaning 1 variable. Okay. So I don't know why I'm writing it all completely. So this is 1 var. And then from there, once you hit that, you get the table with x there, and then you fill it up. Okay, let's do that. So we'll start with that one, 71. Sorry for that. This is 83, 88, 91, 92, 92. And as you can see, these two repeat. So they give us what we call the mode, if they ever ask, okay? And then we've got 95, 97, 104, 108, 109, 110, 111, 115, and 129. So I've got 15 entries there, and I know I have 15 people, so this is good. And then now from here you press the AC button. Sometimes it's written off button at the top. So what is the function here? It is to store data. That's why you need to hit it. So it has a very important function of storing the data. Okay, we do that. And then let's start again. What is the next step? The next step is to start with the shift button. Okay, from shift, we press button number 1. Okay, and then what do we do from there? We will see that option 4 is written var, or variables, or variable, because we're dealing with just a single variable. So we're going to hit var, and then from there we can repeat this as often as we want, because it can give us something like the mean. This can give us something like the standard deviation in terms of x, and that is essentially what we need from here. The other variables are not so important. So this is what we can get with this option. So we just repeat that, and then we hit the option for that, and we hit the option for that. So again, guys, this is just how you think about this. So let's answer 1.1. So we're looking for the mean, so this is option 2, which is that x bar. Okay, the x bar is essentially 99.67 kgs. Remember, the unit of measurement is always going to be present. So we get that mark. So 1.2. It says calculate the standard deviation. Okay, so the standard deviation is that 1. So we start the process shift, press option 1, we press option 4, and then now we press option 3, and that gives us the standard deviation, which is 14.06 kgs. Okay, because this is a mass. Okay, all right, okay. Is the standard deviation going to have to be expressed in kgs or not? I don't know. It is a distance per se, or the variability of each data point from the mean. Okay, on average, of course. Let's leave it at that. So this was 2 marks. Okay, and then they're giving us 1 mark for that. Not a problem. And then we're going to do 1.3. It says, what percentage of weightlifters fall in the featherweight division if the criteria is that the mass must be below 1 standard deviation of the mean? Okay, so this is below 1 standard deviation from the mean. So let's find out what is 1 standard deviation below the mean. This is going to be basically the mean minus 1 standard deviation. That's what it is. Okay, so this is not IST, this is 1 standard deviation. Okay, so the mean is 99.67 minus the standard deviation, which is 14.06. So let's see what is that weight. 99.67 minus 14.06. This gives us an 85.61 kilograms. So we are saying we want essentially weights that are below this value. Okay, so now if we look at this, the weight that is this weight over there and 83. But all these others, 88 going forward, is greater than that value. So there's just 2 people there. So we can say then the percentage of weightlifters is going to be equal to, what is their number? There's just 2 of them. Over how many? 15. Then we multiply that by 100%. So let's see, 2 divided by 15. Oh, by the way, we're in the wrong mode. Okay, let's just wipe this mode off. So this is going to be 2 divided by 15 times 100. So this basically gives us a 13.33 to 2 decimal places percent. So that is it. So this is how you work this out. So as you can see, it's 3 marks. Calculating that weight, which is 1 standard deviation below the mean, and actually identify how many people there are in there. So that substitution of A2 is important, and we get that mark over there. Okay, 1.4. Now questions like this, where there's a bit of a change from the scenario, is always there. Okay, so please familiarize yourselves with these kinds of issues. So we're told here the weightlifters lose 3 kilograms. Now what will be the mean mass of the weight? So to answer 1.4.1, we know that, well, the new mean is going to be the old mean minus 3 kgs. old mean was 9.67. Then we're going to subtract the 3 kgs. So let's see. 9.67 minus 3 is 96.67 kgs. Okay. So this is very easy. But sometimes you guys are never prepared for such questions. What you need to do, you go back to these individual data points, you subtracted 3. As you put them onto the table, you subtracted 3. Again, the mean, we know that x bar is going to be these values, these individual values, plus 71 minus 3 plus dash 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 dash, and then you keep doing that. And at the end, you divide by 15. Just see if you're not getting the same value. There's always, nicer ways of doing things, quick ways even. So this is where we get the marks, not a problem. So 1.4.2. We knew that it would change essentially, and it would decrease because the numerator is decreasing while the denominator stays the same. All right. So we expected a smaller value, so we can accept it. Now what about the standard deviation? Now remember, we're contracting each data point by 3. And the mean also contracted by 3. So this means the standard deviation should stay the same. So the standard deviation is going to remain the 14.06 kgs. Right? So it should not change because everything is changing essentially equally. So this is how we get nice way to God. I even nice in bed. Okay, maybe this question could challenge some students, but not all, because it is a question that needs you to understand how to use equations like this and what does it mean when things change a bit logically. So let's get to question 2 quickly. Question 2 says the box and whisker plots. So I've done a video where I've shown you how to do this. Shows the wages, this is salaries of workers in rands. Again, pay attention to the unit of measurement at 2 companies for the same type of work. Why would 2 companies pay differently? Depends on the packages. Maybe the one that pays less, workers are given, free houses to live in. Sorry, that belongs to the company. Maybe there is even a transportation from the company. So you see, it's a very good one. They don't lose money. And maybe the one that seems to be paying more, you are on your own. You have to rent your own space. You have to travel on your own. All they want is you at work. So it depends on what the package is. So don't think the company that pays less is probably not, favorable, or the one that's paying more is actually favorable. It depends on what they have for you. The other issue to consider is that probably the one that's paying less is actually, what can we say? The company that's paying less people is probably ripping people off. We never know. And then the one that's paying more is trying to attract more people to come and work for them. Again, this boils down to production and also supply. Maybe the company that's paying less is actually experiencing some financial difficulties, but to keep the company going, they have to cut down on salaries. While the other one that's paying more, it has everything working. So there's a lot of reasons for that. But, in the background, always try to consider this in reality, because most of your logic is going to come from that. Okay, let's see. Both companies have 20 workers. Again, pay attention to totals. These are things to make sure you understand. Now let's see company A. Now, we know that this dot represents the minimum. Okay? And where does this one come to? It comes to 200. Okay, and this 200 coincides with what? With the Q1 of company A. This is Q1. And we know that Q1 represents 25% of the data points, right? I don't know why my throat always acts up when I start doing things. This is 25% of all data in there, okay? So that means from 0 to that Q1, that represents 25% of this data. Great. So that is number 1. Number 2, what else do we see? Well, I don't know why I changed my pen. And then now the next thing is we've got here a Q2. Okay, so this is Q2. Now this is the median of this data point of company B. So again, the median, we know it represents what? 50% of the data points in here. This is the true median, Q2, whereas Q1 is the median of the lower half of the data points. And then we're going to have also a Q3 right there, okay? So this is a Q3 of company B, all right? But now this Q3, we know that this represents 75% of the data points in that. Again, Q3 is not the true median, but it is the median of the upper half of the data points. But now where does it come down to? It comes down to 400 rands, right? But now there is a coincidence. It coincides with Q2 of it coincides with Q2 of company A. So this is again 50% of those data points. Not a problem. And then we keep moving, and then we're going to say, well, there is the maximum. This should be the maximum. This is 100% of the data point. And then essentially we can see that this is at 600. But again, there is a coincidence here as well. So what do we see? The coincidence that we see is the fact that that Q3, which represents 75% of that other company, essentially coincides with the maximum of company B. Then the maximum of this company is essentially at 800, okay? So these are things, guys, to make sure you look at and fully understand. Otherwise, if you don't understand them, they will attempt to understand you. Okay, so this is Q1 for our other data point, which is basically 25% of those data points. So the box and whisker diagram is something you need to understand in this regard. Of course, when they put them side by side like that, you want to make sure that you have mastered your tricks. So again, let's look at that minimum. The minimum for this company A is 100. Okay, so that's the minimum value. Okay, great. So now we can start answering some questions because we can understand a few things. It says state whether the following statement is true or false. All the workers at company A, which is that one, earn more than 25% of the workers in company B. Is that so? Well, let's look in there. Can we see the minimum value? Let me highlight it. I don't know how. The minimum value of company A coincides with what? The 25% mark of company B, which is the Q1. So can you see the minimum salary in company A is actually above 25% of company B, and therefore this statement is definitely true. So we can safely say, to answer question 2 quickly, we're going to say, well, 2.1.1, we can say this statement is true because we can see that the minimum coincides with 25%, which is Q1 of company B. Great, so 2.1.2. Okay, it says now comment on the skewness of the data of company B. Well, we can see here there's more space here. Let's just show you. So what we can see there, maybe this one is not so visible. So what we can see there, you can see this area is bigger than that area. This is the space above and below Q2. So if there's more space above Q2 to Q3, it means there's more data points than there are below that area, between Q1 to Q3, of course, around Q2. So we can see that this is a distribution curve that would be something like this. Okay, and that means this is our median, which is Q2. So essentially, you can see there's more area than there is on the other side. So that is skewed to the right. So we can say that this is skewed. So the side of the greatest area in and around the mean is the side of the skewing, right? Sometimes it's called a positive skewing. Positively skewed. So positive means to the right, okay? Easy stuff, ne? So that is a mark and this is a mark. So let's go 2.1.3 says, now which company has the biggest range? Okay, now motivate your answer with necessary calculations. That's easy. Let's look at company A. The range is going to be the maximum minus the minimum. This is going to be company A is 800 minus the minimum, which is 200. So this is 600 rands. Remember, this is money at the moment. Okay, and then for company B, we know that the range is going to be, we just jump in on this one, the maximum there was 600 minus the minimum, which is 200. So this is going to be basically 400. Ne? You're lying, the minimum is 100. What am I doing? Yewena. So this is 500 rands. So as we can see, we can say therefore company A company A has the biggest range. Okay. So we've already calculated of $600. Okay, so again here 2 marks. So for this you get 1 mark, and for declaring which one is bigger, it's those other 2 marks. I mean the other mark. So this is 2.1.4. How many workers? Can you see how many workers at company B earn more than 200 rands? Okay, this is a good question. Very good question. How do we answer this question? Now we've got to look at company B and see 200 is exactly the 200 is Q1. Okay, so meaning people at Q1 and below earn less than 200 rands or up to 200 rands. But now we want people are earning more. So this means from Q1 we're going to the maximum. And of course, Q1 represents 25%. So that means the rest of the 75% actually earns more than 200 rands. So we can just simply say the number of workers is going to be, now remember this is percentage. So this is basically 75%, which is 7 over 100, multiplied by the number of the workers, which is 20. So this should give us the number. Let's put it on the calculator. 75 over 100 times 20, it gives us 15 workers. Okay, great stuff. So understand what these things stand for and how you can use them. So this is very great. So again, ratios and proportion is stuff you learn in grade 8, grade 9 or so. So it should be easy. Okay, so identifying this percentage is very important, that there's going to be 75% of people, because I mean up to 25% are earning less than 200 up to 200. So when you say more, that means it's the remainder of the people, so which would be 75%. So again, the answer there is the mark. Okay, let's quickly finish up 2.2. So 2.2 says the table of data showing the price, okay, of crude oil at the end of each year in US dollars to the nearest dollar per barrel is given. Okay, so we can see the year, we can see the price. Now, which one should be the X variable and which one should be the Y variable? The years should be the X variable, because prices depend on the year, what has changed, climatic conditions, political rubbish that they did in 2020, a lot of nonsense that can happen, can affect how much money you make each year for probably the same service. So the price is essentially the dependent variable. So please be able to understand, or at least assign which one should be which, or else you will get this wrong. Sometimes they don't indicate for you, so you have to know how to assign what to what. Dependent is what basically changes to affect a change on another. That's the dependent variable. Okay, now this is all calculator work, folks. Essentially 2.2, all we do, we're just going to press our mode, and then we press the stat option. But this time from that stat option, what do we do? Mode, stat, and then we're going to press this one, A plus BX. So that is the, what is this? The regression line for bivariate data. Here we've got bivariate data because we've got two variables basically, X and Y. Okay, so we press that option 2, and then what we see here is going to be the table that has X and Y, and then we just fill it up. Okay, let's start. We start with the year 2011, and then we go on to 2012. That's when I started working. 2013, 2014, 2015, 2016, 2017, 2019, 2020, the year of a lot of rubbish, 2021. So how many years? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I've got 10 data points, so that's good. So you can just use your arrows to move around. 2011, but make sure you check. 2011 went with 90 on the Y, and then 2012 with 92, 2013 with 98, 2014 with 54, 2015 with 37, 2016 with 54. Again, this is what you would call the mode on the Y values. That would be the mode. And then this one with 60, which is 2017. Then this one with 61, that is 2019. That went with 49. Then that went with 75, 2021. Okay, so everything looks filled up. And then from here, press the AC button. It's also written off button. And the purpose of this step is to store data. Okay, so there we are. Now, what is next? Again, we're going to press Shift and then we press button 1. So press shift 1, and then here we're going to press a regression. This is reg, so I don't know what option is that on your calculators. So it's written REG, which is regression. So when we press them, we can get A, we can get B, we can get R, which is the correlation coefficient. Okay, those are the three things that we probably need. So just repeat this to get each one of those values. Okay guys, so let's do this one. It's nice and easy. So what does it say? Determine the equation of the least squares regression line. Okay, that's easy. So 2.2.1, we know that this equation is written as A plus BX. Okay, so how do we deal with that? We need A and B. So first A is going to be equal to, so you do this procedure and then you press the option for A. That is the first option. So it gives us a 5965. Comma to 2 decimal places is going to be 51. Okay, and then B, we repeat the procedure again, shift 1, then regression, and then we press option 2 there for B. It gives us a minus 2,93 to 2 decimal places, and therefore we can say now there is our equation complete. It's 5965,61 minus 2,93x. That's the equation of the least squares regression line. So it's very easy. It's all calculator work, guys. You get a mark for each one of those and then putting them together. So 2.2.2. We are being asked to do the correlation coefficient. This is R. Okay. So again, we repeat the procedure. Shift 1, reg, and then we go for the option for R. So this one gives us a minus 0.49 to 2 decimal places. So this is a negative correlation to suggest that as the years go by, we are effectively dropping in terms of our prices. Okay, so that is said, because then it means your company over the long run will be losing money. Okay, so that was easy, 1 mark. So it says now use the calculations to predict the price of crude oil in US dollars. Can you see? US dollars per barrel at the end of 2018. Now the question is, where is 2018? If you look at 2018 is within this domain. So this means this is an interpolation. So it's an accurate prediction per se. You see? Because we are predicting within the domain of our independent variables. So this is easy. So this is 2.2.3. We know that our issue there is this one. So it's going to be 5965,61 minus 2,93. For x, we just put 2018. This should give us the amount in dollars. So for dollars, we can write that. Okay. Be careful when they ask you such questions. If you mess up the unit, you are essentially asking for trouble. Okay, so all you do is just punch that on the calculator. It gives us a $52.87. Okay. Now it says discuss the validity of the answer that you obtained by using your answer in 2.2. Well, normally we could easily say this is interpolation, or the 2018 is within the domain of our independent variables. But now they're forcing us to use the correlation coefficient. Well, now we have to decide on the strong or the strength of that correlation. How well correlated are these two variables? Essentially, this is 0.5 rounded off to 1 decimal place. which we can see that this is a fairly strong, it's not really strong, but it's a fairly strong correlation. So so this means this answer is valid. So we can say the answer then, this is valid, since there is a fairly strong negative correlation between the two variables. Okay guys, I'm writing a lot. I should not be writing a lot. So basically it just said comment on that correlation coefficient. It's a fairly strong negative correlation, and we can see 2018 was also yet another drop instead of a rise. So this is what we would expect. So essentially the answer here is the mark, and the comment on the correlation is the other mark. So now I'm a cry nice, boss. So let's get to analytical geometry. Now that is something. So this involves grade 10 and 11 mainly. There's very little from grade 12 that you would do here, but remember, it can come. So for analytical geometry, I'll tell you something. There's what I would like to call the doctor's approach to solving things here. So do the doctor's approach. What is that doctor's approach? Let me outline it quickly. So essentially, guys, this doctor's approach, you won't find it anywhere, okay? Unless I write a book and then you can find it, okay? This is just my thinking. Now, basically, a doctor, when you get to the doctor, so basically, to the doctor, they take what we call the history. So you tell them what is going on, which is the subjective part. What do you feel? When did it start? What is associated with that? Does it get better when you do this or do that, or when you take this or that? You know, the history taking. And you will be told that almost 60 to 70% of the time, from the history, you would know what the diagnosis is if you're a good doctor. So this means if you read these statements that are given, so basically read given information. If you read that given information with understanding, you'll probably know exactly what you can do. And then examine the patient, right? Because the doctor, after taking that history from you, they will examine you. How do they start? They start by so-called inspection. They look at you and observe certain things in you. Then they start touching and feeling certain areas in you. And maybe an examination is not complete without some, tests and stuff. But that's usually to just confirm a hunch they have. Okay, so meaning study these diagrams that are given and make sure you understand them. Okay, then you can make a provisional diagnosis, meaning what can you do with all of this, right? As I often show you. Then put it to the test, meaning you are ordering your x-rays, your bloods and stuff. This essentially means you're going to perform certain calculations. This is usually when you are answering the questions. So this step is when you are actually answering, because all that you thought you could do is going to be tested there. So this is answering and essentially performing some calculations, whether you are asked or not. And then you basically integrate information, right? Because now integration is when you have done your calculations, you need to actually ascertain that your answers are correct. Because doctors, after they've made a diagnosis and confirmed it, then they will integrate the knowledge they have on the topic and tell you about prognosis, whether you're going to get better and after how long, and what you can do, how will that affect your work, and what can be done about it. Essentially, this is when you just use all math knowledge to link ideas now, to try and answer more effectively some difficult questions, and at the same time you are checking if your answers are correct and making sure you followed the correct principles. Ne. So that's what this is all about, guys. So let's demonstrate what we're talking about. In the diagram, A, coordinates 2 and 6. So where's A? There you are. Okay. Now B with coordinates 11 and 1. So there's B. Okay. And then we have C with coordinates -1 and -3. So there's C there. Okay, great. So we can see that we've got all those coordinates are vertices of triangle ABC, and we can actually see that. Now point is shown on the diagram such that BD is parallel to BC. Sorry, is perpendicular to BC. So we can see there that the angle is 90 degrees there. It's indicated. So if it wasn't indicated, you indicate. Okay, and then N is the x-intercept of BC. Okay, that is obvious. It's on the x-axis. So if that is the case, it already tells us that N is some x value and 0, because an x-intercept, by definition, y is equal to 0 there. So we know that all we're interested in is the x coordinate, because the y coordinate is essentially being given. Then AON is theta, so that is indicated, not a problem, and that's it. Okay, now the question is, we've done our history taking. At the same time, we've been kind of studying the diagram and examined it. So you see, some of the things you can do concurrently. For example, if you're going to a doctor and then you're talking to them about your problem, the doctor is listening while observing you. So they're already starting the examination from already your history. Can you see that? So this is what we're doing. Now, we're doing a proper examination now, which is essentially more driving us towards a provisional diagnosis. What can we do here? We've got coordinates on CA. Then we can use that to find the gradient. The gradient can help us to work out theta. From the gradient, and using one of these points, we can actually find the equation of that line. Number 1. Number 2, we've got also coordinates on CB. That means we can find the gradient of CB. And the gradient together with any one of these points, we can find the equation of BC. From the equation of BC, we can work out the coordinate, the x coordinate of N. Okay, that's also good. Then we've got points on AB, and we can use those points to find the gradient of that line. From the gradient of that line, together with any one of these 2 points, we can actually work out the equation of that line. And that's about what we can do. And then D is given to us without any coordinates. So this is basically some value x and y. So despite the fact that we know that DB is perpendicular to CB or BC, we can only find the gradient of DB using perpendicular lines, but we cannot find the equation or even the coordinates of that point without additional information. So here we need more information to either find the coordinates of that D and essentially the equation of this line. We can, because we can find the gradient using the gradient of BC and using the point B to find the equation of the line. But the trick is we cannot really be sure that we can find those coordinates. So this is when we're doing our run through and essentially trying to do our provisional diagnosis. Now we're going to put it to the test. How do we do that? We start answering the questions. Let's go for it. So 3.1 says, if the gradient of BC, can you see, is a third, okay, that, and the gradient of AC is 3. Okay, they're calculating it for us already. Calculate the x coordinate of N. Can you see that? Easy, not a problem. So we're going to say find 3.1.1. We know that the gradient between MB, or let's say NB, or BN, let's just say NB, is going to be equal to the gradient between B and C. Why? We know that C, N, and B are collinear points, meaning the gradient between any two of collinear points is going to be the same. So we are trying to use that. So we're going to say y at b minus y at n divide by x at b minus x at n is going to be equal to the gradient of BC. We're being told it's a third. So we work it out using those points. Y at b is 1 minus y at n is 0 over x at b is 11 minus x at n is just x is equal to a third. From here we just perform our famous gymnastics of cross multiplication because it simplifies our lives. So since we're interested in x, we just multiply 11 by 1, it's going to be 11 minus x times 1 is minus x equals 3 times that is just going to be 3. Okay, great stuff. Now what do? We can see there therefore that our x is going to be, we transpose x to that side, becomes positive. We transpose 3 to that other side, becomes negative. 11 minus 3 is 8. Does it make sense? Well, if this is 11, it's not so much of a distance from b to n. So we can accept that value for n. So there is the answer, guys. So can you see it's not so difficult? So what is most important here is the substitutions. Okay, so the next mark is for the answer because that's what we're interested in. So can you see? Easy stuff. Now it says calculate the size of ACB. So this is what we're interested in. We're interested in that angle. So what do we do with that? Now look at this. So look at this yellow triangle right there. Okay, so what do we know? We know the gradient of this line. Okay, this means we can find this angle there using the gradient of line BC, but that angle is the same as this angle over there, right? These are vertically opposite angles, so we can find that inside angle using the gradient of BC. 2, we've got the gradient of AB, so that means we can find theta, and that means we are looking for this angle, so we can use the exterior angle because theta becomes the exterior angle of the scaling triangle NCO or ONC or CON, whatever you want to call that. So again, can you see here, this is when we integrate information. So sometimes when you look at certain things, certain questions already can ask a question from a lot of knowledge that you already possess. Then you just plan it quickly and then you start answering. As you can see, it's not a walk in the park, so it means there's some steps. So first let's find theta. So we know that tan theta is going to be equal to the gradient of AC. There you don't have to explain. The gradient of AC is 3. Okay? So therefore theta is going to be the arctan of 3, which we can just quickly get right. So shift, okay, I was still in the stat mode. So let's get out before we run into problems. Shift 10, 3. So it's going to be 71, 5, 7 degrees. Actually, stay away from rounding off too soon here. Let's leave it to 3 decimal places so that we can protect that answer. We can also say here, we know also that 10, let's call this one B and T. At least we've got T on that line. So we can say B and T because we want to use that as a means to an end. It's going to be equal to the gradient of BC. Again, you don't need to explain that. That one we were given that it's the third, right? So we know that therefore our B and T is going to be shift 10 of a third. Again, this is going to give us an acute angle, so we are sorted shift 10 of a third. It gives us an 18,435 degrees to 3 decimal places, because we are trying not to round off too soon. Now we can say then, in triangle, stage where you're working, guys, you will be so happy you're doing those things. CON. In triangle con, okay? What do we know about triangle con? We essentially know that this angle ONC is essentially equal to triangle BNT, which is going to be equal to 18,435 degrees. Why do we know that? These are vertically opposite angles. Yes, so use the diagram as best as you can, but there are certain declarations that have to come out. We can say, well, we also know something, that this angle ACB, which is what we want, plus this angle ONC should give us the angle, what did they say, AON. Okay, now again, what is the reason? This is an exterior angle. Exterior angle of a triangle. Now, which triangle are we talking about? CON. So this implies that ACB plus ONC, we have just found out this is 18,435 degrees. Right. Right. Which is going to be equal to AON is basically theta, so this is 71,575 degrees. So therefore our angle ACB is going to be 71,575 degrees minus 18,435 degrees. Okay, so 71,575 minus 18,435. It gives us a 53,14 degrees answer. So can you see the answer ends up being to 2 decimal places? Easy stuff. So a little bit of planning is important, and of course 5 marks already tells us that we have multiple steps to consider here. So basically this is important and that is important. But maybe that one is a means to an end though. Maybe this one is not important. The mark is here because it is what we are trying to get to for the second story. And then for the third story, we can just simply say correct substitutions into a correct formula and the answer. So that is the stories that gave us those 5 marks. Looks like we have only 3. 1, 2, 3, 4. Okay, maybe maybe one of the statements is important to give a mark for, or maybe those calculations, it doesn't matter. Let's go on. 3.2 says determine the equation of AC. Now AC, so this is easy. You can see that the y-intercept is the origin, but remember, they warned you, these diagrams are not usually drawn to scale, so you may actually be in trouble. So as much as you can see that, which sometimes it's fair to just think of it that way, but we also have to be worried. So we can say, look, AC, line AC is such that y is equal to, the gradient of AC is 3, then it's going to be x plus c. So let's not be careless and assume that that is the case. We're just going to substitute any one of those points. We've got A, which is that point there. So this means 6 is equal to 3 into 2 plus c. Therefore, you can see that c is 0. Therefore, y is basically equal to 3x. So again, it means you could see it, that is your provisional diagnosis, but then you have to put it to the test to confirm it. Otherwise, so this substitution is important, guys, and that final answer is important. So this is how those 2 marks are scored. 3.3, it is further given that D lies on AC. Can you see now? D lies on AC produced, meaning this is the straight line. Now if you produce AC, to D, obviously, now they are telling us that, but we can break this up and say, this is stuff like that. But now we can see that if that is the straight line, because the word produced means we are looking at the same straight line, and essentially that means D and A and C are collinear. Now we have enough information because we can derive equation from that and derive an equation from that. We can work out the coordinates of D. So again, you can see this question is packed with some marks there, 5 marks. So it says now such that BC is perpendicular to BD, which is fine. Now calculate the coordinates of D. Can you see? Now we knew we were limited in our approach, or at least in what we were given. Now we are given enough information to attempt to do simultaneous equations there, because that's the best way we can go about it. So 3.3, we know that, well, what do we know? We know that essentially the gradient, we can use the gradients. The gradient of, say, the gradient of BD multiplied by the gradient of BC, it should give us a -1. Why? It is given that BD or BC is perpendicular to BD. We know that perpendicular lines have their gradients multiplying to a -1, or those gradients are inversely related, or these are negative reciprocals of one another. So now we want to use this piece of information that this is going to be y at D minus x at B. Superb. Y at B over x at D minus x at B. This is into the gradient. Now here you want to limit struggling. The gradient of BC was already given to us that it is 1/3. This is -1. This means y at D is just y at D minus y at B, it's 1 over. Now x at D is basically just x at D minus x at B, it's -11, is equal to, so when we divide it by 3 throughout here, what happens? This becomes a -3 over 1. And then we just simply do our famous gymnastic that makes our lives a lot easier. This implies then we can just say y at D minus 1, because we're multiplying that by 1, is equal to 3 times x at D. It's actually -3 times x at D, plus -3 times -11 is going to be plus 33. Okay. Now we can essentially express y at D as -3 x at D plus 34. When we transpose 1, we can make this equation 1. So here you need to know how to plan your attack. You can say also, I know that the gradient between, say for example, AD is the same as the gradient between AC. Right? Why? Because I know that C A and D are collinear points because they belong in the same straight line as given by that extra bit of information. This implies that y at D minus y at A over x at D minus x at A is equal to the gradient of AC. We were told it's 3. So this implies that we've got y at D minus y at A is 6 over x at D minus 2 is equal to 3 over 1. Again, famous gymnastic of cross multiplication. So here we're multiplying this by 3. So we can simply say, look, y at D minus 6, because we're multiplying that by 1, it's going to be equal to 3 times x at D minus 3 times minus 2 is minus 6. Can you see these ones cancel? Because they are the same sign on either side of the equal sign. This implies that y at D is equal to 3 times x at D. So we can make this one equation 2. As you can see, each one of these equations represent y. So we can say then, what do we see? We can see that minus 3x at D plus 34 is equal to 3x at D. Yeah. Whew. Yes. Why is that? We can see that equation 1 is equal to equation 2 because all of that represents y at D. So there's plenty of ways to deal with these issues. So technically we can transpose that to that side and rearrange. This implies that 6x at D is equal to 34. Therefore therefore x at D is going to be 34 divided by 6. It gives us a 17 over 3. Okay, what is that? That is 5,6. So essentially 5 is not that bad. It's not that bad. Okay, seeing that this is 8 here, so it's not that bad. So which means also y at D. Then we can take this and substitute into any one. So the simplest is equation 2. It's going to be 3 into 17 over 3, which is 17. Therefore, D is the point 17 over 3 is to 17. Okay. So that's fine. That's fine. Now, does that make sense? Well, we just have to accept it. At least it's a point in the first quadrant. Everything is positive, so we can go with the flow in there. So guys, this is how we score these marks. So it's a lot of work. You need to plan. This is like a math essay, okay? Or a short essay. Anyway, for me, what matters is finding that equation. And the other one is finding the second equation. And then putting one into the other is important. And then working out the x coordinate and working out the y coordinate. So this is 1, 2, 3, 4. 5. So those marks are there. So being a cry nice nala. We just needed to know how to put things together. Okay. So that is good, guys. So we move on. Alright, so I'm a cry nice before 2. Let's go to question 4. This is still analytical geometry, but this section is purely for grade 12 now. This is grade 12 analytical geometry. But it doesn't mean the principles from previous don't apply. So the doctor's approach still applies, okay? Let's go on. So we're just going to go ahead and do it. So when you've practiced this long enough, you'll be able to deal with it. So in the diagram A, with coordinates -3 and -11, And C, where is that? So there's C with the coordinates 1 and 3 are points on the circumference of a circle with diameter AB. So AB is the diameter. So this is very important. Yo sandla samvele satatazela. Ingengomntu otatazela kakhulu nje. Siyatatazela. Khona umancane ondihlekisile lapha kwezinto zakhona. Hey, utata ngoJesu utatazelayo. Anyway, let's go. Center. So basically, guys, the other story is, if we're being told this is the diameter, it means somewhere, somehow, we're going to have a center, right? So my center may not be exactly in the center because it's an estimation now. So we've got a center there, and they're telling us that this is the center T. So now this is going to be X is to Y because we don't know those coordinates. But that is the center. Okay, not a problem. And then we're told the equation of AB is 3x plus 20. So we can see that the gradient of that line AB essentially is 3. Okay, maybe it's going to be useful somewhere, somehow. Now guys, sometimes with this grade 12 question, they don't give you so much information. So let's just do analysis and then complete it. We can see that we've got points on AC. We can use those points to find the gradient of AC. From the gradient of AC, we can essentially, what is this called? We can essentially get the gradient. From the gradient together with any one of these points, we can find the equation of AC. From that equation of AC, we can actually find the y-intercept of AC, which is over there. Okay, not a problem. And what about the coordinates of T? I don't think we have enough information here to do anything about the coordinates of T. As well as we don't have enough information, because if we don't have the coordinates of T, we cannot use any form of symmetry to find the coordinates of B. So even the coordinates of B is X and Y, which we don't know. So we have a lot of unknowns here. So we don't know the coordinates of B, we don't know the coordinates of T. And there's very limited bit that we can find here. So we also won't know the coordinates of D right here, which is the y-intercept here. So we don't know that. So even D is going to be X and Y. So it's a question mark on its own because we don't have enough info. Okay. So folks, we are in for some trouble here. Let's go. Next step, once we've examined and we can't confirm anything, we put tests, isn't it? Yes, sometimes when you can't find any clues on the examination, this becomes the test that can actually unlock a lot of pieces of information, if you're choosing well, of course. Now let's answer some questions. Determine the equation of the perpendicular bisector of AC. So now if we're cutting AC in half, where will that perpendicular bisector pass? We don't know. So the midpoint of, so let's just assume it passes through the center. We don't know for sure though that it does pass through the center. We don't know. We're just assuming now. So we're going to call this one the perpendicular bisector. We're just going to write it PB, but this is not lead, okay? Perpendicular bisector, PB. So if it bisects this line, it's going to cut it in half while it is itself perpendicular. Okay, now what is the significance of this story? Look at that. If this line is perpendicular to AC and it cuts AC in half, it definitely passes through the center because that's theorem 1. So can you see, we know that this perpendicular bisector essentially passes through the center T, because for it to cut a chord of a circle in half while it is itself perpendicular to it, then it is a line from the center. So this perpendicular bisector essentially passes through the center of the circle. So now we are sure. Okay, So can you see, guys, this is integration of information. No manga business. It says now show or determine the equation of this perpendicular bisector. So can you see this one might help us to find the coordinates of t now? Because once we find this equation, what is left? We already have the equation of AC, so these are simultaneous equations, so we can solve simultaneously to find that center. So we're going great. But now we have a situation here. Our situation is that we don't know this point, the midpoint of AC. So we've got A, B, C, D, and then we can call this one point E. Also with coordinates X and Y, which we need to find. So this one is easy because it's the midpoint of AC. So let's go. 4.1. Now this says, let's say let E, X is to Y, be the midpoint of AC, such that E is going to be X at, say, A, plus X at C over 2 is to Y at A plus Y at C over 2, right? That is the midpoint expression, which implies that E is going to be this X at 8 minus 3 plus 1 over 2 is 2, 11 plus 3 over 2. Okay, therefore our point E is going to be, this is minus 2 over 2, it's going to be minus 1, is to 11 plus 3, that's 14 divided by 2, that's 7. So does it make sense? Yes, it's a point in the second quadrant, negative X value and a positive Y value. So we can accept that. We needed that point, because without that point, we would not go very far. So now we can see that we can accept the values for that. So we can see that this is minus 1 and 7, now that we've calculated it. We needed that point. So again, what do we know? We can say also, we also see that the gradient of the perpendicular bisector multiplied by the gradient of AC should give us 1. Why? We know that the perpendicular bisector is perpendicular to AC, ne? Perpendicular lines, or you can even say here, yeah, let's leave it at that. So now the gradient of the perpendicular bisector multiplied by, here I'm going to jump in, the Y at, say, A is 11 minus Y at C is 3 over the X at A, it's minus 3 minus 1 is equal to minus 1. Therefore, the gradient of the perpendicular bisector is equal to, maybe let's do it properly, is equal to 11 minus 3 is what? Is 8. 8 divided by minus 4, it's minus 2. Minus 2, when we divide by minus 2 here, we get a half. Yeah. So it makes sense because that's a positive gradient. It's a positive gradient. So looks like we are good. Looks like we are good. So we can say this implies we can say then the perpendicular bisector as a line is such that Y is equal to a half of X plus C. Then we're going to use point E, which lies on that graph, which is minus 1 and 7. So it was key to get that right. Is equal to a half into minus 1 plus C. Therefore, the C there is a 7 plus 0.5, right? This is 15 over 2. We can say therefore that line is given by a half of X plus 15 over 2. Okay, let's see, 15 over 2 is 7,5, ne? And that is a point above point E. That makes sense, okay? So we can accept these. It's a positive gradient and a positive y-intercept in the right region. So this we can accept. Okay, so that's cool. That's cool, guys. So can you see, again, this is a bit of a math essay again. It's one of those high order questions that you just need to understand the tricks of solving them. Now we're getting 4 marks here. Again, the marks is solving point E, essentially, and finding the gradient of this, essentially, and that substitution and leading to the final answer. So this is how we score those 4 marks, nice and easy. So 5A1, 4.2. It says now show that the coordinates of the center of the circle are -5 and 5. So can you see it's 3 marks? So this question is difficult. If you did not realize that this line, the perpendicular bisector, will pass through the center, you wouldn't have a clue as to what to do there. So this is a higher grade question, but provided you can integrate your knowledge properly. So again, this is another question that is teaching you something. We can just say T lies on the perpendicular bisector as well. Okay, or we can just simply say T lies on the perpendicular bisector. What is our motivation from that? It's a line from center perpendicular to midpoint of chord AC. Can you see? You can justify that and say, look, this is theorem 1 basically. Integration. Then, therefore, it means T is a point of intersection of AB and the perpendicular bisector. Right. Such that, maybe let's say it implies therefore that T is a point of intersection of AB and the perpendicular bisector, such that we can see now that we equate the two equations. The equation of AB was given as 3x plus 20 is equal to this one. We got the perpendicular bisector. It came out as a half of x plus 15 over 2. Yeah. Then we simply solve for x. This implies we move that, so 3 minus a half is 2.5. Right, 2.5 is 5 over 2x. Is equal to, then we've got our 15 over 2 minus 20. So it gives us a minus 25 over 2, okay? Therefore, our x at t is going to be equal to, then we simply divide that by 2 over 5, 5 over 2. Be careful on what you're doing. So this is minus 5. Kitchen. So we got it. So there's a lot of statements that needed to come out, especially this one, this realization. And you can see it came from a bit of an inspection that came from that statement. So guys, I cannot overly emphasize, therefore y at t is going to be, we just choose any one of these equations that we can see. So it's going to be 3 into minus 5 plus 20, which is going to be minus 15 plus 20 is just basically 5. So we can say therefore t is essentially minus 5 is to 5. So this was a hidden higher grade question. They hid it by using 3 marks and hiding as much information as they can. you had to realize it on your own. Okay, bafowethu, this is easy. So for me, equating these two equations is what is key, and finding each one of those points and essentially substituting this one into any one of the others, I guess, is what matters. And the rest is history, guys. This is how these 3 marks are arrived at. But you needed statements to make sense of all the situations. So I don't know, you can check the official guidelines as to how you get marks for this, but for me, that is valid to do. So let's go. 4.3 says calculate the length of AB. Again, AB is the diameter. So now we've got the coordinates of T. The coordinates of T is -5 and 5. So we know that AB is twice AT. So this is easy. So we can say AB is equal to 2 times the size of AT. Okay? I mean, that one is, you can say diameter is equal to 2 times the radius of a circle. Okay, that's if you need to really justify for that, which is equal to 2 times the distance formula for AT. So it's going to be x at T minus x at A all squared, y at T minus y at A all squared. This is 2 times the square root. Y at T now is 5 minus y at A, it's 11 all squared, plus y I x at T, it's -5 minus that one, it's going to be minus is going to be +3 all squared. Then y at T is it's 5 minus 11 all squared. So let's do that quickly. So we've got 2 into the square root of -5 plus 3 squared plus 5 minus 11 all squared. So we're getting a 4 square root of 10. So here we can leave it here. We don't have to we don't have to do decimals, but if you want, you can do this to 2 decimal places. It's not a big deal. It's not a must. That's fine. And then it says 3 marks, by the way. So we were getting substitutions and knowing that we're going to have to multiply that by 2 and the answer. Or if you liked, you could actually by inspection find the coordinates of B. Okay, since we have the center and we've got A, we can actually get the coordinates of B. So you can start asking yourself, from A to T, how many units did we go? This is -3 to -5, so we went 2 units. So we're going to take this one 2 units to the left as well. So -5 minus 2 is going to be -7. Okay, makes sense. And then we ask for our vertical distance from A to T. That was 11 to 5. We went down 6 units. So we then take that one 6 units down. 5 minus 6 is -1. So you can actually find the coordinates of B by inspection, and then you state it. Then you use the distance formula between A and B. So however you want to do that, it works. So let's just show you how you could go and do this. So you can say here B is the point -7 and -1 by inspection. So you don't have to justify this. You can say then AB is going to be the square root of x at b minus x at a all squared plus y at b minus y at a squared. Ish, my chest, Baba, is betraying me. Yam betrayer. So this is minus 7 minus 3 squared plus y at b, it's minus 1 minus 11 squared. So when you punch that onto the calculator, we get the same answer, 4 square root 10 units. Okay, so this is what you could have done before anything happens. So for this one, you would get a mark for getting those coordinates, substitutions, and the answer. So this is how you go about it. Here's about 4, and I'm losing time. 4,4. It says now write down. Question that says write down the equation of the circle. It is highly important to just do this one. The x plus the y plus the r squared. First, let's start with the x. It's going to be x, minus the x coordinate at b is going to be plus 5. This is going to be y minus 5. Okay, great. Now what is the radius? The radius is half the diameter. So this is going to be 2 root 10. 2 root 10 squared is going to be 4 times 10, which is 40. So this is great. When they say write down, you just write down. But you know you have to work things out. Okay. So that's it. That's it. So just in case you're wondering how I got all of this, it is from this business right here. You know that you would have to say x minus 5, which is going to be x plus 5 all squared into y minus 5 all squared. I almost forgot the square there. Is equal to, now, half of the diameter. You can just say half times 4 root 10 all squared. So this is what gives you that answer. But when they say write down, this is what you do on your notes or your rough work, basically. You do it on the side to work it out. But what they're interested in is the final answer. So you're getting a mark for this, that substitution, and that substitution. So this is how those 3 marks are scored. Ish, perfect. 4.5. Now, we told you the tangent to the circle at A cuts the y-axis at 0 is equal to P. So now let's demonstrate. Where is the tangent? Where is the tangent at A? So so there is the tangent. We're just going to write it 10. Can you see? It is the tangent at A. And we're being told that it cuts the y-axis at 0 and P, so I'm just showing it that this is where our y-intercept is. Don't worry about the cluttering now. Now, we are told here, calculate the numerical value of P. That's easy. So this is basically a question of saying find the equation of the tangent. Then we know that the constant is equal to P in that equation. Is it not? So what do we know? We know that the angle between the diameter and the tangent is 90 degrees. So we can use the fact that the gradient of AB, we know it's 3. Then we can find the gradient of the tangent and use point A, then we are sorted. So we can say the tangent is such that y is equal to, okay, maybe let's not start there. We can say the gradient of the tangent multiplied by the gradient of AB is equal to -1. We know that the tangent is perpendicular to diameter. Okay, easy. this implies that the gradient of our tangent multiplied by the gradient of AB, which is 3, is equal to -1. Therefore, our gradient of our tangent is going to be -1/3. Okay, makes sense because that's a negative gradient and it's less steep, so it's good. So we can say now then the tangent is such that y is equal to -1/3x plus c. Now through point A, which is -3 and 11. Plus c. So we substitute there. Therefore, our c value there, this is going to be +1. When we transpose into the other side, it's going to be 11 minus 1, which is 10. Right. So at this point, the c value gives us our p value. So I don't know if we need to show there anymore. We can just simply say therefore p is equal to 10. All right, great. So this was a means to an end. We didn't have to complete it, bearing in mind that the equation of the tangent is going to be -1/3 of x plus 10. But that was not the question. We just used it as a means to an end. That's what you can put in your notes, and you know for sure that the constant term becomes the y value at the y-intercept. Isn't it? So we're getting how many marks there? 3 marks. Okay, so getting the gradient of the tangent is important, and substituting into that equation is great, and getting that stories there, you know. I don't know. Where's the 4th mark, guys? I don't know about where to. Maybe we can gift you a mark for knowing the fact that these ones should be like that. Maybe. Because there's nothing wrong with that, even if you didn't show the equation. So let's just go on. I'm losing time. That is what I can see here. 4.6 says, if the circle through A, B, and C, A, B, and C, this is the main circle, is moved 3 units to the right. So that's a horizontal translation. So this means x values are changing. And then 2 units up, that means y values are changing. And the radius is halved. Write down, again the question says write down the equation of the new circle. So this is easy. Again, we need an answer here. So we know that, well, the equation of the new circle will be such that we have a square there and another square there and whatever else we got. Now, we are suggesting, now let's just take it from our notes here. This is what you would do on your rough work again. So we know that we're going to take x plus 5. Sorry, x, remember, when we move something to the right, we subtract from x, so it's going to be -3 plus the original 5, all squared, plus y. That was plus, we're moving it upward, plus 2 units, then plus the original 5. No, that was minus the original 5. All squared is going to be equal to, now we're halving the radius. The radius is already 2 root. So we've got a half of 2 root 10. And then we're squaring that. So what do we get? So this is going to be x plus 2 into y minus 3. Can you see that? Yeah. Exactly. So that is the stories. Ah, Lord. Whew. Yeah. So what was did we at any point find the equation of that circle? Yes, we did. So that was the story. So when we're moving it to the right 3 units, we subtract 3 from the x values, and then while we add what was there, and the other one we add 2 to the y values while we put everything as it was. And then now half of root 10 is just going to be root 10 squared, which is basically just going to give us 10. So that's the equation of the circle. So that was the answer. This was your notes, which you can write on your rough work. We don't need to see it, but you can show it on the side, but not on the main answer. Because sometimes if you run into problems on the main answer while you did well on your rough work, you just say CRW. So how to answer is also very important. Okay, so that is done, guys. So again, you get a mark for this and a mark for that and a mark for that. So that is 3 marks. Nice and easy. So 4.7. So let's finish up. A new circle with equation. Can you see there? We're given this equation with center P, okay, is given. Will this circle intersect the original circle? So the original circle is this one. Great. So will that intersect? Motivate your answer with necessary calculations. Now there's a few things to think about. From what we are given, the center P is going to be the opposite of what is there. So it's going to be 2 is to the opposite of what is there, which is 3. Okay. And then the radius R of P is going to be the square root of that, which is 2. Now let's review some notes. If we've got circles like that, and let's say they intersect at 2 points, can you see the center of this circle is there? The center of that other circle is there. So what matters now, what helps us to do, is the distance between their centers. So the distance between their centers, because this is circle P, this is circle T, right? Because the center was T. So we know that basically PT should be equal to, not equal to, but PT should be less than the radii RP plus RT. This is when they intersect at 2 points, which is at this point over here and at that point over there. Okay, so this is the condition for that occurrence. Okay, now we need to establish another setup. This is circles that intersect. Now the second way that the circles can intersect is if this circle intersects circle center P and T at only 1 point. So there is the center, there is the center. So this is circle P, this is circle T, the original. Now the distance between their centers, we can see here that PT should be exactly equal to RP plus RT. This is the condition that says these ones intersect at 2 points, and this one says it intersects at 1 point. So if we find these two, then yes, that is true. But the third scenario, it's when this circle is like this, and then the other one is like that with its center there. So this is circle P, circle T. So what do we see here? We will see that the distance between them, PT, is going to be greater than RT plus RP. Okay, so if this is the condition, it means these ones don't intersect. at all. And the fourth condition for circles that we can think about, it's when we've got this circle, it's center P, right? Circle P. But they are concentric. This one can be inside the other one for the same center. This is circle T, right? So if they are concentric, again, they don't intersect, but they share the same center. So we know that P is basically equal to T. If we find the same center, but we know that RT is greater than RP. Again, this is another position to ensure we're correct. So those are concentric circles that don't intersect. So we can already see here that the centers are not the same, because the center here is -5 and 5. The center here is 2 and 3. So already this one is out. We don't have this situation. Then let's test the distance between their centers, because this is what matters now. So we can say now the new circle new circle has the center P, which is going to be 2 and 3. RP is basically going to be 2. That's what we need. So now what do? We can say then the distance between their centers, we can say PT is going to be equal to x at t minus x at p all squared plus y at t minus y at p all squared, which is going to be y at t was 5 minus, no, there's no minus, it's -3 all squared. Actually, I'm starting to make mistakes again. X at t is -5 minus 2 into y at t is 5 minus 3 all squared. Put it in the calculator. -5 minus 2 all squared plus 5 minus 3 squared. So this gives us a square root of 53. Now let's see, what is that? Here we will need to take it down to decimals. This is necessary. Now to 2 decimal places, this is 28 units. Okay, so PT, which is the distance between the centers of these circles, is that. But now let's see, what is RP? Also, RP plus RT is going to be equal to the radius of P is 2 plus the radius of T. We saw that the radius was 2 root 10 there. This is 2 root 10. So what is that? 2 plus 2 square root of 10. This is basically 8,32 units. So what is the story now? Now can you see the sum of their radii is, let's see, yeah, that was 4 root 10. What did we get there above? Yeah, 4 root 10. Now we can see that there's 2 issues now. RP plus RT is greater than PT. Can you see that? So this is the situation. PT is, no, wait. PT, so we satisfied this. We satisfied this one. So we satisfied that one. So we can say, therefore, the 2 circles will intersect twice, since PT is less than RP plus RT. Nice and easy. Okay, so that was a higher grade question. You had to know what you're doing to get it done, okay? So that's another thing. So yeah, la 4 marks la bedlalwa ngengqondo yakho pha. So bafowethu, for me, what matters is this calculation and that calculation and this conclusion, and essentially that step is critical. The rest is your problem. So we're taking this 23 marks. Of course, for a math student who is well prepared, I'm a cry nice la. Isn't this kalagash? But for a math student who was not prepared, yeah, this could have been both, you know, a happy and a sad story at the same time. It's a bittersweet type of a feeling. Anyway, anyhow, let's move on, guys, to question 5. Let me just drink something quick. Okay, bafowethu, let us quickly get to question 5. So this is a question that mixes a bit of grade 10, 11, and 12. So let's go for it. 5.1, we're told here, theta is a reflex angle. So if theta is a reflex angle, it means on our Cartesian plane, x and y with the origin there, it means our angle theta is either here or here, because a reflex angle is either in the 4th quadrant or in the 3rd quadrant, okay? And we're told here tan of theta is negative. Can you see? So tan is negative in the 4th quadrant, so that means that is cancelled. So we have a reflex angle theta like that. So this is our theta. Great. So this is very easy. Now we know what to do. It says now, without the use of a calculator, determine with the aid of a sketch the value of what we have. So 5.1, we know that tan theta is minus 3 over 4. Then we can make our terminal arm diagram on the Cartesian plane. Since we are interested in the 4th quadrant, this is the origin, this is y, this is x, and we know that our theta is this angle here. So we will always anchor it there. So this should be 90 degrees, and now we can see that the negative side is basically the y, because 10 is opposite over adjacent. So basically the opposite side is minus 3, the adjacent is 4. So our task is to work out the hypotenuse. So we know that x squared plus y squared is equal to r squared. We get this one from Pythagoras theorem. So this is 4 squared plus minus 3 squared equals r squared. Therefore r is the positive square root of what we've got there. So this is 16 plus 9, that's 25, so it gives us a 5. So r is always positive, so you can't keep the negative sign. So we can see that this is a 5. So this is very important. So we've got two ways of looking at this. You can look at this negative angle, which is going to be minus theta. It's going to be the equivalent of positive theta. So, but don't show both. So show once on your sketch. Don't show these two angles there. You're going to be dead. Now let's start answering. 5.1.1. We're told the sine of theta. Sine of theta is going to be opposite over adjacent. So, opposite over hypotenuse is minus 3 over 5. So that's it. This one is quick. So we're getting a mark for that. And the other mark is working on the sketch. 5.1.2 says the cos of 2 theta. Now that's a double angle identity, so we can use this one, cos squared theta minus sine squared theta, because this is easy, right? Now cos squared of theta is basically, cos is going to be adjacent over hypotenuse, this is 4 over 5 squared, minus sine squared is minus 3 over 5 squared. So at this point, we were told not to use a calculator, so you're going to burn if you started finding an answer here. So this is going to be basically 16 over 25 minus 9 over 25. So basically this is easy now, because it's just going to be 16 minus 9, which is yo tenda ngayikhumbula. So this is 7 over 25 basically. So let's just see. You can just use your calculator to confirm, but don't show up with the answer. You have not shown how you got 2. Yes, I'm getting 7 over 25. This one, if you show up with a decimal, you are dead at the same time. So we don't want any decimals here. So how many marks are we scoring? 3 marks. So the first one is defining cos and sine in the answer. So this is how the 3 marks are. Okay. Of course, that double angle expansion is important. So identities cannot be forgotten here. 5.1.3. We are given here the cos of theta plus 30 degrees. Again, we can see here we've got a compound angle expansion for cos. So we're going to have cos theta cos 30 degrees. The sign changes to sine theta sine 30 degrees. Now cos theta is by this diagram, so it's going to be 4 over 5 into cos of 30 is root 3 over 2 from special angles, so don't forget them. Sine of theta here is minus into minus 3 over 5. Sine of 30 is just a half. Okay, so again here you're not allowed to do things that are crazy, so this is going to be essentially the situation. So we got here 2 root 3 over 5 plus, because negative times a negative is going to be a plus. Here we don't do anything, it's going to be 3 over 10. Now the common denominator here is 10. Now 5 to 10 twice, 2 times that is going to be 4 root 3 plus 3. Now here don't use a calculator, that's the answer actually. That is the answer right there. Once you go further than this, it means you used your calculator and you're going to be killed. So we're getting 3 marks also. Here I think the most important is these special angles. 1, 2, and then the answer. Because the rest is your problem. I mean, cos and sine you already defined above and got marks for. So that's how it goes. So let's go for it, guys. 5.2. It says now if x is equal to 4 sine theta, find 4 sine alpha, and y is 4 cos alpha, calculate that. Easy. X squared plus y squared is going to be equal to, what is x? Is basically 4 sine alpha. Now we are squaring that, plus y, it's basically 4 cos alpha all squared. Now when we square that, we get 16 sine squared alpha plus 16 cos squared alpha. Now 16 is the common factor. So here when you're simplifying any trig expressions, you are using the so-called 3-step approach. Now how do you know this? Watch my other videos on a very clean and detailed approach of using that. At this point, I'm only going to apply it. So if you're feeling like you're left behind, I'm sorry guys, I can't do everything every time. So if it is there, look for it and you'll find it. So this is 16. Again, trig identities, that is 1. So this is basically 16. So we are doing great. So how many marks were we getting here? 2 marks. So the 1 is for identifying that identity and the answer. So that was it. There was nothing to that question. So 5.3 says simplify the expression to a single trigonometric ratio. Again, this is a common question. Sine of 900 degrees minus x times cos of minus x minus the sine of x minus 180 degrees times sine of 90 degrees plus x. Okay, so again, using our 3-step approach to simplify this, this is the same as sine. So first we need to express this as something that we can reduce. So we know that 360 by 2 is 720. So this is 2 times 360 degrees plus, we're going to add now to 900. Let's see, 900 minus 720 is 180. So this is going to be plus 180 degrees minus x. Okay, so that's fine. So this is what we're going to do, but we can put this one inside the bracket. Times cos of minus x minus sine of x minus 180 degrees times the sine of 90 degrees plus x. Okay, once you're changing something, always try to change one thing at a go. Otherwise, it starts becoming a bit silly. So following our 3-step approach, so this is a multiple of 360. Reduction formula is by 360, so we ignore that too. So sine of 360 plus, this means in principle we're in the first quadrant. So this is the same as sine of 180 degrees minus x times cos of a negative angle is a positive cos x minus sine. Now sine of 180 minus theta, x minus 180. Think of these negative angles. This is 180 degrees when you're going clockwise, but going anti-clockwise it becomes minus 180. But then when you add a positive x, so we are forcing it to go this way, and x is essentially always thought of as an acute angle. So you can see this is an angle in the third quadrant. So now if you don't understand this, again watch the other videos I've done. So this is the same as minus sine of x. Now times, now sine of 90 plus x, this is in the second quadrant. Sine is positive, but because of 90 you're going to use the cofunction of that, which will follow the sine of the original. So this is how you do that, and then you further reduce this. This is in the second quadrant, so this is the same as positive sine x cos x. This one, negative times a negative, is going to be a positive sine x cos x. Now you can see these are like terms, so this is 2 sine x cos x. And then finally, using our identities there, this contracts to just sine 2x. It's a double angle identity for sine. So that we have completed. So again here, to be sure that you've done this reduction correctly, put a value for x and solve. Put a value down there, substitute a value for x in that original expression. If the answer is the same, you are sorted, but your challenge may be these multiple brackets, which can scare you a bit. So this 6 marks was easy, guys. Essentially, where is this 6 marks? Well, this is a reduction, this is a reduction, this is a reduction. This is essentially 3 marks. And then this whole shenanigan boils down to just that sine x. that is the 4th mark. And then sorting up to this one, that's the 5th mark, and contracting it, that's the 6th mark. So this is how this question is taken down. So 5.4, let's move. 5.4, we're given an identity to prove. So we have sine of 7x plus sine x over 2 cos 3x equals to sine 4x. Okay, great. So now let's inspect this. We've got a 7x against 4x. And we can see that we've also got x and then 3x. So the side that looks more complicated is the left-hand side. So it's much better to work with that. Okay. Now it says prove the identity. So we've got 5.4.1. We need to identify that the left-hand side is basically sine 7x plus sine x over 2 cos 3x. Okay. Now what are we going to do? Now we need to be smart. We can see that we've got 3x there. And in 7x, we've got 4 plus 3x. And already we're trying to get to 4. So we can split that 7x into 4 and 3 because of that denominator. So now as you work these kinds of expressions, please be very vigilant. Sine of 4x plus 3x. Right. That's still 7x plus. Okay, now let's leave that sine x for a second. So we've got 2 cos 3x. Now, our problem is that sine x becomes the odd one out. Right? Because now it's starting to look different. But we don't want to work with things that don't look alike, because this reduction will force us to yet another reduction. That is a lot of steps. But if we're scoring only 4 marks, it means there's not so much we need to do. So there's a lot of things to consider, essentially. So what we're going to propose is the fact that, can we change sine x into these angles? The answer is yes. So this is going to be sine of 4x minus 3x. Now that looks better because we've got angles that we can handle. At least that should look okay. Otherwise, we will have a long calculation. Unfortunately, here we need to expand. So this is sine of the first angle times cos of the second angle. The sign in between doesn't change. This is going to be cos of the first angle times sine of the second angle. Okay. Plus, we do the same here. Sine the first angle, cos of the second angle. The sign doesn't change. Cos of the first angle, sine of the second angle. I'm sorry for the space there. Became a bit too limited. So this is 2 cos 3x. Okay, so we've got like terms to deal with. So we've got sine 4x cos 3x. So we've got sine 4x cos 3x, and it is positive. So those two add up to 2 sine 4x cos 3x, right? Right. And then our next set is a positive cos 4x sine 3x, and then a negative version of that. So those are like terms, so they simply cancel out and disappear. So we've got 2 cos 3x. Ah, Lord. Now we can see again we've got a common factor there and there. So they essentially divide to 1, and then that also divides to 1. And what are we left with is the answer. So this is sine 4x, which is equal to the right hand side. Nice and easy. So here it takes experience, obviously, to work with these things, and experience is gathered from practicing regularly and taking different versions of these questions from different years. Then that will make you better. And again, you watch comprehensive review sessions, and there's more than enough in my channel. Almost all the papers I've done, I always try to walk you through every single little bit of information that you need to work this out. Now, where are these marks, folks? Essentially, technically, and you know it very well. I would believe that this expression is important, and that expression is important. It was not given. Right. And the expunctions for both the general expunctions are where the marks are, okay? The third mark. And essentially, boiling it down to the step, maybe this is where the 4 marks are. I don't know, okay? All right, okay. So maybe this is how the marks are, or we can say that expunction and this expunction is important, and we can essentially say this is how the 4 marks are scored. It doesn't matter, because cancellations is not really a big deal, is it? And handling like terms is not really so much of a mark-worthy thing, because that's just algebra or arithmetic. So Bafweto, now attempt to take it from this side to the other side and see if you will succeed. But let's leave that to you. Tell me how it goes. Ne? Yeah. So this is 5.4.2. It says now, for which values is the identity, for values of what is the identity above undefined? We don't know what values of what, but it doesn't really matter. We will see. Determine the general solution of x for which the identity is undefined. I think this is the correct question. As for this other statement, it sounds gibberish to me. Unfortunately, I have to be critical, even though I know I'm no saint to this, but basically, when is this identity undefined and we want the general solution? It is when the denominator is equal to 0, because we can't define by 0. So we know that this is when cos 2 cos 3x is equal to 0, all right? Which implies that cos 3x is equal to definitely 0 when you divide by 2, which we can say therefore 3x is going to be, arc cos of 0 is plus or minus 90 degrees, which is the biggest angle there you can get, plus 360 degrees, okay, plus k times 360 degrees, where k is an element of the z's, the integers. Here when also equivalent, therefore x is going to be equal to, because general solution is for x, we divide by this, is going to be plus or minus 30 degrees, plus k times 360 by 3, this is 120 degrees, where k is an element of the integers, and that's the solution. Maybe let's not rush to conclusions there. All right. That is the story, guys. So this is easy, no? So basically, get a mark for equating this to 0. It's important. Otherwise, you wouldn't know what to do, would you? Exactly. And essentially, there's 2 solutions, because there's 2 of them. Plus 30 and minus 30. Done. 3 marks in the bag. So let's do 5.5. So 5.5 says, determine the general solution of x if this is the case, okay? We've got here 2 sine of 3x plus 20 degrees equals 2 cos of x. Now, when you've got this angle, compound angle, which is not the same as this angle, and you've got sine and cos on either side of the equal sign, then it means we're going to use co-ratios here. So we can divide first by 2. This is basically sine of 3x plus 20 degrees is equal to cos of x. Now we can change that. This also implies that sine of 3x plus 20 degrees is equal to, this must have been sine of 90 degrees minus x. Now you reverse this, because we know we can reduce this to cos x. So that is the most important. Now, what matters is that when you've got sine and sine, even though these angles are not the same, it means they should be the same if these two are equal. Ne? So we can say now this implies that 3x plus 20 degrees is equal to, this is going to be essentially that reference angle 90 degrees minus x plus k times 360 degrees, or 3x plus 20 degrees is equal to 180 degrees minus this angle 90 degrees minus x plus k times 360 degrees, where k is an element of integers. So I'm sorry for the space there, I'm just trying to be as cautious as possible. Now we let things move around, so we're going to have 4x is going to be equal to 90 minus 20, that's 70 degrees, plus k times 360 degrees, or we sort this out. Essentially, this is going to be plus x. When it comes to this side, we get 2x is equal to, move 20 to this side, so it's going to be 180 minus 90, that is 90. 90 minus 20, that's 70 degrees, plus k equals 360 degrees, times 360, where k is an element of integers. So let me just double check here if I'm doing the correct thing. So negative times negative is going to be plus x. When you transpose it becomes 2x. Then 180 minus 90 is going to be 90. Then we subtract 20, 70. Yeah, this is good. So we can say therefore our x is going to be equal to 70 divided by 4 is basically 17,50, because they told you to 2 decimal places if you can, and then plus k. Now 360 by 4, this is 90 degrees, ne? Yes. Or x is going to be 70 by 2, this is 35 degrees, plus k times 180 degrees, where k is an element of integers. So this is how you can do this. Of course, there's many solutions for this question. You could have changed sign to cos. You would get slightly different solutions, but it doesn't mean the answer is different, because if you put down the values for x, you will actually get the same results. All right. So here there's plenty of solutions. It just depends on the approach. So keep it simple when you can. There's no need for any trouble. For what is important for where to is this step more than anything. That is very important. And essentially, each one of these solutions is important. So that is already 3 marks. And this situation is also important. So we can see here that we've got 1, 2, 3, 4, 5. So where's the 6th mark? Maybe this simplification, because the rest was pretty straightforward. So again, ngamakry nice la ngokwasho kwendoda yaseNewcastle, la baba ubaba lo kanye ubhuti uthi ngamakry nice. I think bebekunikeze amakry nice indeed. So let's move, guys, without wasting time. Question 6. Question 6 is the trig graphs, which again I have taught you the best ways of looking at this so that you can get maximum marks. So look at any video I have done on paper 2 mathematics. I'm telling you, you will start to realize these things are a cupcake and you just chow them and they are soft also. Okay, now in the diagram, the graphs of f of x equals 2 cos x. So I always do my analysis there. So this is the amplitude, which is basically 2. This gives me a maximum of 2 and a minimum of -2, right? That is the first thing. Now, that is what I can gather from here. And then if I look at x here, the coefficient of x is 1, so it means the period is just the standard 360 degrees because there's 1 there. So we're going to say period is 360 over 1, which is 360 degrees. Okay, great. And then what does this lead to? It leads us to working out intervals, because intervals is always going to be period divided by 4 from the 4 quadrants. Now this is going to be 360 degrees divided by 4, which is 90 degrees. So this thing has to be moving at intervals of 90 degrees. Do we see that? Yes, the graph of f is definitely moving in intervals of 90. Can you see the critical values happen at 90 and 180, at least on this half? And then on the other half, of course, 0. And then we cut it short because this is not a critical value right here. This is just a path the graph is still taking. So can you see? Now I've told you about the critical values. It tells you about the spaces between the critical values. I will not tell you what those are. Watch my videos. There's short and long videos on this. But I'm just trying to show you how you can apply your knowledge. So we can identify that definitely f has an amplitude of 2, as we understood it, and that's the maximum value, which is exactly that. And we're moving at the scale of 90, so basically that is what is happening. So we've interpreted that graph, and it's pretty easy to see what's going on. Now let's look at another graph. So we've got the graph of g, which is 2 cos x. Okay, so here what we will note is the fact that the coefficient of our function is an invisible one. This one suggests that the amplitude is 1, which will give us a maximum value of 1 and a minimum value of -1. Okay, that's important. And then this 2 here, the coefficient of x, tells us that the period here is going to be 180 degrees. Why? Because you take 360 and divide by the coefficient of 2, and it gives you 180. I'm not going to go about it. And then if you look at that, it gives you intervals of the period, which is 180 divided by essentially 4 quadrants. This gives us 180 divided by 4 is what? Is 45. Why didn't I think about it? 45 degrees. So the intervals will lead us to the critical values, because the spaces between the critical values, which you should know what those are if you watch my channel regularly. So can you see this graph from 0, the first intercept or critical value is 45. And then the next one is 90 when it reaches -1. The next one is 45 later, which is 135. The last one is 180. So can you see it moves at intervals of 45. So this is what actually gives you the graph nice and easy. So guys, if you don't know these things, I'm sorry. You're going to ban, okay? And these are very simple questions, because this is basically grade 10 and 11. There's nothing grade 12 here, but maybe somewhere, somehow, you may have to apply grade 12 principles, but it is mainly grade 10 and 11. So you should crack this thing with your eyes closed. Now that we understand what is going on, and luckily the grid is proper, let's go. It says write down the period of g. Can you see the period of g? We could see that it's 180. We worked it out. So 6.1, we know that the period is going to be 180 degrees. Of course, you get your 1 mark and you move on. 6.2, don't know why I had to write this, it's not important. It says now again write down, that means answer only, the x values for which the graph of f is increasing. Increasing means positive gradients. Now let's look at the graph of f. This is the graph of f. Can you see, if we draw a tangent line on this side, see it's a negative gradient. But if you draw a tangent line on that half of this graph, you can see this is a positive gradient. So this happens, I mean, at the stationary points, this gradient is 0, so we don't want that. So what does that mean? It means this is the interval we are looking for. Essentially, it's here at 0, and minus 45. And we can simply link these two. But at 45, it still has a positive gradient at that point. So we can shade this one. Say that one is included, but 0 is not, because at 0, the gradient is 0. So we don't want a gradient of 0, but we want a positive gradient. So how do we answer this question? So we can say 6.2x must be less than 0 degrees, but greater than or equal to minus 45 degrees. Usually for this notation, you get 2 marks, 6.3. It says now write down the range of 3 times g minus 1. Ne? Easy. So for me, when they say write down, it says answer only is cool, but there's a few gymnastics you need to perform. First of all, what is the range of g alone? The range of g is basically the y values, which is an element of, now let's look at g. The amplitude is 1, meaning the maximum is at 1 and minus 1. So this is minus 1 and 1. Now, we're multiplying that by 3. So this means the next situation is going to be y, an element of minus 3 and 3, because we just simply multiply those by that. And then the last one, now we subtract 1 to those y values. So we're going to say here y is going to be an element of minus 3 minus 1 is minus 4. 3 minus 1 is going to be 2. So this is your answer. So you work it out that way by understanding the influence of multiplying the function by 3. Okay, so now you write down your answer here. You can say here the range, okay, is an element of y values, right, such that y is less than or equal to 2, greater than or equal to minus 4. You can put it that way, or you can write the range is such that y is an element of minus 4 is to 2. So you can choose how you want to write this answer, but I like this. It looks more complicated and mathematical at best, because you are trying to tell me that you understand what the range is. Okay, so maybe we can even say the range is equal to that story, or the range is such that y is an element of. Nice and easy. So I would give you 2 marks for that notation. And again, you can see what we did here. We just started with the normal graph, and the graph of g, you can see there is cos of x, so the amplitude was 1. You start there, then you multiply those maximum values by that 3, and then you get the next one. Then you subtract 1 from each one, and that's how you get the second. But the 2 marks were in there, so this is your option in case you saw it, you wanted to write it that way. So 6.4 says now determine the values of x for which f of x is greater than f of x is greater than a half in the given interval, meaning from minus 45 to 180. Okay, so you can see here, this one is going to require you to do some sort of calculations. F of x is a halfway. Now this one is not so clear anymore, because we've got a multiple before, so it creates a bit of problems now. Because if there was no 2 there, we would be happy, because we know cos of x is a half at 60 degrees. But now this is multiplied by 2. So this is a bit of a problem, because now this would suggest that we have to change our mind. It won't happen at 60 degrees anymore. So we have to calculate this. So 6.4, we know that. Let's first find what is f of x is equal to a half. Because for us to work out that inequality, we need to find where this f of x is a half. Now this implies that we've got 2 cos x is equal to a half. Then we divide by 2, we've got cos x is equal to a quarter. Right, therefore x is going to be the arc cos of a quarter. Now here you've got multiple solutions that you can find, so you have to be very careful. For me, I like to just put here plus or minus because this is important. Plus or minus this situation, and then k times 360 degrees, where k is an element of integers. For me, when I'm solving, I like to use my general solutions because I don't want to miss a single solution that is in this interval. Okay, so this is plus or minus. Now let's see, shift cos of a quarter gives us a 75.52 degrees to 2 decimal places, and then of course plus k times 360 degrees, where k is an element of integers. Now we can already see here that it's either positive 75 or negative 75. So now what is negative 75? It's basically an angle in the second quadrant here, an equivalent of 75 in the second quadrant, because we only have 2 quadrants here, the first up to 90 and the second. So let's see. So we can say therefore that x is equal to 75 degrees, 75.52 degrees, or x is going to be equal to, now this one is in the second quadrant, it's basically going to be 180. An equivalent of this angle in the second quadrant is going to be 180 minus that. So we can say this is 104.48 degrees. Right. Yes, so why do I have a 7 now here? Is that so? I think it's 4.8, not 7.8. What am I doing? Yeah, that is what we can do. So look at that. So what are we going to say here is going on? So this is probably here, because 45 and 90, 70 is probably somewhere here. I mean, a half is somewhere in that region. So this is 75.52 degrees. And then this situation is only happening there. So basically, where it is a half, as you can see here, this 104 would be something like negative a half, which is somewhere there. So this would be 104.48. So basically, we're not looking for negative a half. We are looking for a positive half. And you can already see that this interval from minus 45 to 0, it's already above 1. So there's no need to consider that interval. So this is basically there. So we have a solution there, that this is going to happen when, therefore we know that x must be less than 75.52 degrees, but greater than or equal to even, because that graph at minus 45 is greater than a half. So it is greater than a half, and this one is either that or less than that, because we can see that during this interval here up to that 75, we can see this graph is above the half mark. It's above that. So that is that interval over there, guys. So this is this. If we wanted to look at it that way. Great. Whew, okay, so this one you just not going to include it because it's not applicable. It's giving a minus a half. It's not giving us a half. Okay, so probably we should not even have entertained that. So that is anyway how we solve this. So 4 marks, this is very good. So I would suggest that we have to do this substitution. It's important. This step is important, and that step is important, and the final finish is important. Or one can easily say the general solutions was essentially a means to an end. It was not the question itself. So we can say for the notation here, you get 2 marks, and for solving for that x, it's important because this is very important. Also though, look at your diagram. You can't just dismiss that without thinking. So that is good, guys. That is good. So we've got our 4 marks. So let's finish up this thing before we start wasting too much time. Now it says determine the minimum value of this situation here in this interval 0 and 180. So they didn't tell us what to use, so we just have to find the minimum value of this thing. Obviously, if you think about it, this is already a square. Now a square is either greater than 0 or equal to 0, but the smallest value here would be 0 for the square. This is by inspection. That means the minimum value should be this one, because then this stays. So that should be the minimum value. So you can do this by inspection, but I guess for 4 marks you can't just write an answer. You'll have to already tell us that since half of cos x is squared, this already says the minimum value we can get there is 0. That needs to come out, and then you can say therefore the minimum value is that one. But then this is in this interval 0 is to minus. I think here there's a catch now. The catch is over there, but I don't think this is related to this question, is it? It's not even related to any of our graphs here, so we can just do that. So there's a few ways you can answer this question. So 6.5. We can say here, since, let me just start here and say, it's not going to be good. Let's just do it here. 6.5. We can say here, we know that half of cos squared x minus a quarter. We can say now, since half cos squared x is always greater than or equal to 0, therefore the minimum value, the minimum value of that expression is equal to 0, because that's the smallest. It's always positive, whether we get a negative value, but because this is squared, it's always going to be positive. So the minimum value is 0. So this means, therefore, that the minimum value of a half cos squared x minus a quarter is going to be equal to minus a quarter. For me, that is a determination and a half. So you can look at it and see what you can do. But I think we can say this is important, and probably we can give you 2 marks for the answer and say this is how you can score the 4 marks. You don't need to sweat here. You just inspect this thing and you work it out nice and easy. Or how else would you do it? You can just make this one a function of x. You can say let f, maybe let's not use f of x. Let's say let h of x equals a half cos squared x minus a quarter. Right? Then we know that 4 a minimum value, it is such that h of x prime should be equal to 0, right? First of all. And then this implies that we derive here, so it's going to be by the way, the derivative of a of course is going to be sine, but is it minus sine? Yeah, when was when. But for me, I would cheat here, guys. I don't know if it is allowed. This is squared, so the variable is cos x as a whole. It's not just that. So this is going to be basically cos x, is it not? Because this is cos x all squared. So I could really cheat here and say this cos of x should be equal to 0. And then if that is the case, that means my x is going to be equal to plus or minus 90 degrees. Is it not? Yeah, because that is the story. And then of course plus k times 360 degrees, where k is an element of integers. Is it allowed to cheat? This is when you look at this as half of cos x all squared minus a quarter. I'm trying to take this as an entire variable. You can cheat sometimes, can you not? There you went. Yeah, man. So I'm trying to think. But I don't understand why, because I think it says find the x values for which this is a minimum. Maybe that's the question. But sometimes these guys are crazy, because I'm feeling like if you're just asking the minimum value, that's it. I don't care in what quadrant this is, you know. So I'm trying to think, what are these guys doing here? But yeah, now they are frying my head. You guys are frying my head here. But this one is solving for x. We can say therefore the minimum value is going to be equal to, remember, there's only one value, by the way, here in this interval. So we can say therefore our x should be a 90 degrees, right? Why? Because minus 90 is essentially 270. 270 is outside the upper limit of our interval. So we cut that out. So we can say therefore the minimum value of h of x is going to be a half cos of 90 degrees, that is squared, cos squared 90 degrees minus a quarter is that. So we know that cos of 90 is 0, so that thing remains 0. So this leaves us a quarter still. So bafowethu mina ngiqedile le ndaba. So it means in this interval, that is what is happening. Of course, I cheated there, but if you do the derivative there, I think the derivative of course is going to be a minus sine x of some kind. But now this is cos squared x, so that should be perhaps a minus sine squared x. Either way, we are fine. And then you work your things. I don't know, guys, but I think I would choose this one. I would choose this approach. It saves me from a lot of unnecessary stress. They didn't ask me for the x values for which this is a minimum. They said determine the minimum value of this expression in this interval. And we can see that if we approach it the way we know how to do calculus, but being silly at the same time, we're getting a quarter. And essentially, which we could easily get by just looking at it, even if we didn't care where the x values are or the y values are. So our answers are correct by 4-2. And yeah, we just move forward, because this is going to be a bit difficult, you know. Yeah, hey, but this question, I win. Tingathi andenza umnqwazi wami awuqini apha. Kutheni umnqwazi wami angaqini la? hayi kodwa bafethu methi iyaxoka isoze zindethe kwaphela ne ingandibhayizisa nje. I think my first approach is better because it does not care what is going on. But if you did it this way, taking cos x as a variable per se, as in you can say let this be x, for example, and then we can solve this essentially eventually like that, and this can solve our pain. So guys, I don't know how you look at it, but whatever. For me, I would say, look, this derivative here is important, and finding this x value is important, and now substituting into this thing is important, and finding the answer is also important, because I don't see any better way. So guys, Lamakrai nice 13 marks, we go with them home. Okay, so there's plenty of ways to kill this cat. You skin it, or you shoot it, or by all means kill it. That's what is the message. By all means kill it. Let it be dead. Whether you starve it or you do, but here in the exam your execution is time limited. This suggests that whatever you do, it has to be something that can work within reasonable time. Because if you are starving it, it's going to have to first lose weight, get dehydrated, and then start to have electrolyte abnormalities, and then the heart starts stopping or running like, I don't know, and then it dies. But here you don't have that much time. So I guess to stab it in the chest and stab the heart will kill it within reasonable time. Poisoning it might kill it within reasonable time. Shooting it might kill it within reasonable time. Putting it inside the sack and drop it fast, maybe while tied to a stone, can make it hit the ground and die. So you see, there's a lot of things you can explore that can actually work within reasonable time. Otherwise, if you try the long route, which is trying to starve it, you will not finish and you are going to die. Okay guys, let's move. In the diagram, AD is a 3 meter vertical pole, and we can see there is AD. So again guys, we're applying the doctor's approach here. Doctor's approach basically, and the 3-step approach. Okay, so this is what you need to do. And if you look at this doctor's approach, basically first here you just look what is given, you calculate all possible angles, and then you start with the triangle that has the most information, at least a given side, so those are the things you do. So maybe we can say probably a doctor's approach, but this one you are going to add, calculate all possible angles. Subsequent to that, you will then start from a triangle with a given side, at least, of course, depending on what you're doing. And then the whole thing goes like that. Okay, so these are some of the things you would want to think about when you answer these questions. And guys, we have lost time, so let's move. We are told here with the support cable or support cables attached at T, there is the support cable 1, and at A, so there is another support cable, so we can make them the same color because they are the support cables. Okay, which is X meters from the foot of the pole. Okay, we can see that X over there. Then D, okay, and sorry, D and R are in the same horizontal plane, so that is important to show that this is the foot of the tower. T is 1 meter above the foot of the pole, and we can see that. And then the angle of elevation of A from R, so this is this angle right here. This is this angle right here. So that angle is theta, and it's indicated, so we are done. TRA is alpha. So TRA is alpha. So I don't know what to use here now. TRA is alpha, so that is indicated. Okay, so they've already worked out that one as well for us, so we are good. Now that we have been given all this information, let's calculate all possible angles. Sorry. So if one looks at this triangle ADR, this is theta, this is 90 degrees. So this angle right here is going to be 90 degrees minus theta, right? From 3 angles of a triangle. Nice and easy. And then from this triangle TDR, we can see this is theta and there's a small component alpha. So this means this one that angle is going to be theta minus alpha. Okay, now we're talking about the smaller one. Okay, so that is fine, that is okay, and that is all right. And again, we can see that this angle right here, it's an exterior angle of some other angle. Maybe let's use the black color now and make it as wide as possible. That angle, you can see this is an exterior angle of this triangle. This is 90 plus the smaller component, which is theta plus alpha. So this is 90 degrees plus theta minus alpha. Okay, so now that we can see all of these stories there, we can easily see that, okay, we've done our doctor's approach and we've got a lot of sides given. So it can be this triangle, it can be this triangle, it can be the big one. Whichever triangle we decide to start with. And of note is that we're going to have to apply our 3-step approach all the way. So now it says show that TR is equal to. Now again, guys, inspect the question. Where is X? X is on DR. DR is a common side for triangle TDR and also from triangle ADR. Okay, so this one doesn't tell us which triangle we're dealing with. But now when we look at this cos of angle theta minus alpha, where is angle theta minus alpha? Is definitely on this triangle. Okay, so literally this means we are working in that triangle. So, and we can see side TR is the hypotenuse side, this angle is that angle there, and X is this side. So this spells out cos of this angle right there, and we can just use that, and we can see it's just 2 marks, so not so much work there. So we can simply say here nicely, to answer 7.1, we can say in triangle TDR. Okay, what do we know? We know that angle TRD is going to be equal to theta minus alpha. Okay, so we can just simply say C diagram, because this is obvious. But that has to come out. We can say then, we can see that cos of angle TRD is going to be the adjacent side, which is DR, over the hypotenuse side, which is TR. Now from just cross multiplication, because then that we have to divide by 1. So we can see here that this implies that TR is going to be equal to DR over cos of TRD. Now we just simply substitute and say therefore DR is X over the cos of that angle, which is theta minus alpha. Nice and easy. So this is done. So that was not a lot. It was not at all. So basically, knowing that you needed to work that angle, you are sorted. You can even say, I don't know what you want to say, but yeah, that's it, man. And then here, essentially, I don't know, guys, but here basically is the substitutions more than the answer, because the substitutions already gave us the answer. So that's it, we are done. Lord, 7.2. 7.2 says prove that x, so now we are proving x here, the yellow guy. X, now x is this side, but now this side is a common side to this triangle and that triangle ADR. So how are we going to deal with this mess? We inspect this thing, so please guys, apply inspection. Now we've got a 2. Where is a 2? There is a 2. So now this is saying we are either working in this triangle right here, or we are working still in this triangle. We don't know, because that is also part of that, but maybe because it is a 2, it's already trying to suggest that this is that triangle that we're working with, but we're not sure. Let's keep exploring. We've got cos of theta. Cos of theta could easily come from from sine of 90 minus theta. When we reduce that using reduction formulae, it could give us a cos theta. So probably this is that angle we're talking about. It's the cos of this angle. Sorry, the sine of that angle could give us a cos theta, maybe. And then we look again and say, what else do we have before true? Cos of this angle. But now the cos of this angle came from this expression. Can you see that? And that expression represents TR. And TR is a side to this triangle. Can you see? Now I'm more convinced we're in that triangle. But now this one gives it away. Sine of alpha. Alpha is only in this triangle. So basically, we are working in this triangle here, the yellow one. Okay guys, so I don't know what happened here now. I realized I solved while my recording was on pause. So I don't know where I stopped. There's no way of tracing it. So I'm sorry folks. If 7.2 is something that I rushed, just read what I have given here. It's a pity you will be just missing all the logic behind this, but I'm sure you will be able to follow, okay? Because now my blunder here, I noticed that my recording was on pause, and yet I solved this question to its entirety. So that's a bit of a blunder. So I hope you will be able to follow, because everything is self-explanatory. So let's just move on. 7.3, apologies for that. It is further given that theta is and then alpha is that. So calculate the area of triangle ATR. So this is the yellow triangle. But now the key is using formulas in 7.1.2. So how would you look at it? If you look at A, for example, AT, we can use this as the base, right? And then the height will fall outside, which is going to be dr. Okay, so that could be that. So you can use that. But the problem with this is that we are only going to use this formula to find x, and we have that. But now it says using the formulas in 7.1.2. So this is an NB. So this means you cannot use this approach. It's dangerous. You have to follow the instruction. So the instruction will force us to use the area rule. So that is what this is going to push us into. So fine, let's look at it in triangle ATR. Now what are we going to do in triangle ATR? We need to find this angle ATR, okay? And if we find that angle, we need to be smart about it. We can say now angle ATR. Did we at any point use triangle that angle ATR? We did not. So we never used it, so we have to determine it. So this is equal to, what is it equal to? It's going to be equal to 90 degrees plus theta minus alpha. How do we know this? This is an exterior angle. Exterior angle of triangle TDR. Yes. Again, here we're just being smart. Which is going to be equal to 90 degrees plus theta we're being given is 68.33 degrees minus 28 degrees. So this is very important. 90 plus 68.33 minus 28. So this gives us a 130.33 degrees. Okay, great. So this is very important to establish, because if we don't establish it, it's going to kill us to use the area rule here. Now we can say also, what do we know? We know that TR is equal to x over the cos of theta minus alpha. That is proved above. So this is what is going to help you to trace things. X is what we need. This is going to hurt, is it not? It's going to hurt. So, it's going to hurt. So we know that also, but, okay, maybe let's just do it, guys. Let's do it. Yeah, this question is crazy now. But x is equal to 2 cos theta, cos of theta minus alpha over sine alpha. Here, let's not do any reasons. This is 2 cos 68.33 degrees, cos of 68.33 degrees minus 28 degrees. So this is going to be sine 28 degrees. They dictated how we're going to proceed here, so guys, we don't have a choice. So when you put that to a calculator, I'm getting a 1,199. Yeah, let's leave it to 3 decimal places so that we don't suffer units. So, which implies that now our TR is going to be 1,199 divided by cos of 28, superb, cos of 68.33 degrees minus 28 degrees. Time is running, 1,199 divided by the cos of 68.33 minus 28. So it gives us a 1,573 to 3 decimal places units. And then now, once we have TR, we are sorted. We can say then the area of triangle ATR is going to be half the base, which in fact the included side is going to be AT times TR times the sine of ATR. That's the area rule, which is going to be half of AT is 2 into TR, which is now 1,573 times sine of that angle there. What did you get? 130.33 degrees. Yo, they forced us into a nice and tight corner. So be careful of questions like this. You've got plenty of options, but they're limiting them. 0.5 into 2 into 1,573 into the sine of 130,33. So this gives us a 1,20 to 2 decimal places square units. Okay, so guys would be told it's time up now. So you are dead now. You'd be told it's time up. So yeah, we've exhausted our 3 hours, but purely because we're revising. I can already tell you, paper 2 is a bit more longer, than paper 1, because here there's a lot of integration that you need to do. So essentially, guys, this question was tricky. If you don't notice, you'll die. They are dictating how you're going to proceed. So what is important is calculating that angle, and calculating the value of x. We don't care. That is 2 marks. And calculating the value of TR. Whew. That's 3 marks. And essentially boiling down to the answer. Now you're not going to get marks for substitutions, are you? Yeah, you're not getting them. So that's it. And then guys, try using the half base times height. You just use this expression to find x, and then use that and see what you're going to get. But you should get the same answer. But be careful of how the question is asked. So this one was a silly question. I'm a cry nicely, but they were fish. Because they were just hiding what is hiding. But anyway, guys, you can see that sometimes certain questions are naughty. Okay, so we're doing question 8. Do we have a question 8 point some change? Yeah. Question 8. Okay. So here we have to prove the angle at center is equal to twice the angle at circumference. So guys, I'm not gonna do this one. This one is for you and your textbook if you don't know what you're supposed to do. Okay. I've done this proof on one of the papers from 2018 if I'm not mistaken. So that video is already a year old. So go check it out. I'm not wasting time on this one because of the time factor. But let's apply the knowledge here, which is 8.2. So I'm just going to do 8.2 here, but don't jump 8.1 for you. O is the center of the circle. There it is. CBE, you can see that C is a point on the circumference, B is a point on the circumference, E. So those points are concyclic, meaning they are on the same circumference. So there we can see those points, and then EC produced. Once you hear that word produced, it means it's a straight line. So EC is a straight line. Then produced to D, it means we have the same line going all the way to D from E. And D intersects OB at F. So there we can see that. What? EC produced meets BD. Oh, okay. It meets BD in D. Okay. So there's BD. Okay. Whatever. Yeah. CD is equal to. So we can see that this is indicated already. That CD is equal to CB. And then we have OE and BE are joined. And then we've got B3 is equal to X. Okay. Hey, not a problem. So, This is something else, don't you think? Don't you think? Yeah, man, we think it is like this. So what can we do with this, guys? So before you start answering, hey, when look, this triangle, this yellow triangle is an isosceles triangle. So what does that mean? It simply means if this angle is x, that angle is also x, right? These are angles opposite equal sides in a triangle. Great. And then what else can we do with this? Well, nobody said DB is a tangent, because if that would be the case, we would know that E2 is also x. But we don't have that luxury, and we also don't know what this is, okay? There is a statement, DB is a tangent to the circle at B. Doch. Kill me for it. I jumped. You see, I don't know why my memory or my thing is just lapsed. So that means that is equal to D2 because of the 10 chord theorem. So we know it now. All right. And then what else can we do, guys? Well. We also know that the angle between the tangent and the radius is 90 degrees. So this means this angle is 90 degrees. So suggesting that this little angle on the inside is going to be 90 degrees minus x. Okay. Great. Is there more that we can do? We just know that these are ready. Suggesting that this whole angle E this is suggesting that this whole angle E is equal to angle B1. Again, angles opposite equal sides in that triangle. So there's not much we can do here, is there? No. Okay, now we just keep answering some questions, because once we start suffering, we move on. So 8.2.1 says name with reasons two other angles equal to x. So we've already identified as the black angles. So we can start by saying angle D is going to be equal to angle B3 equal to x. What is that? This is angles opposite equal sides in triangle BCD. Okay, don't explain too much. Leave it like that. So, and then that is number one. Number two, we also know that angle E2 is going to be equal to angle B3 equal to x. 10 chord theorem. Okay, easy. So those are the so 4 marks like that. 2 marks for each statement and the reason. Okay, easy. 4 marks there. 8.2.2 says now express EOB in terms of x. So this angle right here. Okay, so that's easy. We can look at it this way. If we have to express that in terms of x, the best way to go about this question is to find, we have to find this angle, right? Because that angle is half of this angle, or this angle is twice that angle. For the same arc EB or chord EB, that's the angle at circumference, that's the angle at center. So we can use that yellow triangle to get C2 in terms of x. So we can safely say here, well, angle C2 is equal to angle D plus angle B3. This is the exterior angle of triangle BCD. So Therefore, we know that C2 is going to be x plus x, which is equal to 2x. We can say then, we know that EOB is going to be equal to 2 times angle C2. Right. This is the angle at center equals to 2 times angle at circumference, or at circle. So this implies that EOB is going to be 2 into 2x, which is going to be 4x. Nice and easy. So 3 marks in the bag. So essentially, what matters here? There's quite a lot of things though. Finding C2 is important, and this statement and its reason is important, and everything else that we did. Okay, 3 marks in the bag. 8.2.2. It says determine with reasons the size of angle B2 in terms of x. Okay, that's easy. We know, for example, that angle B2 plus angle B3 is equal to 90 degrees. Why? We know that the tangent is perpendicular to radius. The tangent is BD, the radius is OB, okay? So this implies that B2 plus B3, which is x, is equal to 90 degrees. Therefore, angle B2 is going to be 90 degrees minus x. And that's the answer. Okay, so that was easy. So essentially, that is the statement and the answer. So, that was 8.2.3. 8.2.4 says show that DC is equal to CF. Okay, so let's see. DC is equal to CF. Anyways, DC is equal to CB. So this simply means we can focus on this triangle BCF, because we already know the side that is equal to D. Right, CD is already equal to CB. So now the trick is to say CB is equal to CF. And now this simply says we need to say something about this angle. We are suggesting that we are saying this angle right there, B2 must be equal to F2, right? Because if we can find those two are equal, then we can say this is equal to that, and since this is equal to that, therefore this and that are equal. That's a nice question. Very nice question. First and foremost, we're going to say we need to prove that F2 is equal to B2. That's number one. And we can see that we have already found information that can suggest that. So we can say in triangle BCF, what can we say there? We know that angle C2 plus angle B2 plus angle F2 is going to give us 180 degrees. This is the sum of 3 angles of a triangle. Now what triangle are we talking about? BCF. Okay, now this implies C2 we found that this is 2x plus B2 we found this is 90 degrees minus x plus angle F2 equals 180 degrees. Therefore, angle F2 is equal to what? Now when we transpose this, it's going to be 180 minus x, okay, plus x. Let's just first sort this thing out. This is going to be x. 2x minus x is x. Then when we transpose everything, it's going to give us 90 degrees minus x. What can we say? We can say, therefore, this means angle F2 is equal to angle B2 because each is equal to 90 degrees minus x. So that is important. If that is the case, maybe let's just not say things and say this implies. But now what could be concluded there? We can say, therefore, we can, without a shadow of a doubt, and say CF is equal to, or maybe let's just say DC. What is this CB? Therefore, CB is equal to CB is equal to CF. Okay, why? These are sides or converse of angle. You can say converse of angles opposite equal sides. Okay. Yeah, this is easily the converse, because if we find the angles to be equal, then the sides are going to be equal in a triangle. So we can say this is the converse of angles opposite equal sides, or we can say these are sides opposite equal angles in a triangle. So there's plenty of ways to prove that. We have a but. We can say but. What do we know? We know that CB is equal to DC. Right, that was given. We can say, therefore, DC is equal to, instead of CB, we put CF. That's the answer. Again, each is equal to CB. That's nice and easy. So this one was a bit of work, but nothing out of the ordinary there. Okay, a bit of planning, and you can see how things work out nicely. So where are these 3 marks, folks? The issue here that is important, it is the statement. How you got to it, I'm not interested, okay? That's grade 8 work. But this statement is also powerful, because to prove that, it is very important. The given statement is not so much of a big deal, but the final answer is important, and its reason essentially. So those are the 3 marks. So guys, lama cry nice la, yeah, a bit corner, but that last one perhaps could scare you a bit. Okay, let's do question 9 quickly. Question 9, we are given these sides in a quadrilateral ABCD, diagonals AD and BC intersect at E. Okay, there we are. Then we are given the sides AB is 8 centimeters, BD 15. Now, all you can see here is that you're given the sides, and there's lots of triangles in here, and most likely going to be dealing with a question on proportionality theorem. Okay, so think about that. So it says now, prove that triangle BCA is similar to triangle CDB. So BCA is this triangle right here. Okay, all right. Now that's fine. And then we have this one CDB, which is this triangle over here. So now we are given the sides Bafwethu, so there's an overlap there. So we are given the sides, so we just need to prove that their sides are in the same proportion, because if their sides are in the same proportion, then these triangles are similar. So similarity, you either prove angles or sides to be in the same proportion. So usually you get it the normal way where you're proving angles, but this time we're going to use sides. But now let's see which side belongs where, essentially. Now this is where the tricky part comes, because it's not so easy to tell. But looking at this side and that side and that side and that side, it maybe wants to look something like that. Let's say this is the common side and A is equal to angle D, maybe. We don't know. And if that is the case, it would mean B is equal to that angle, and then that is equal to that. So let's see, 10 over 8, 10 over 18 is basically 5 over 9. Yeah? 5, that is when we're taking that side over this side. And let's see, is that the same as 8 over 15? And it's not. So now that means this approach is not going to work. So let's try and switch it around and say, perhaps what if this angle here, angle C, is equal to that? Let's just check this one. Say that angle is that. So it depends on how we're going to flip this. And looking at this, it looks as if these two lines are parallel. Let's say also this angle is equal to that. We're just being silly. We're trying to flip this triangle so that this is here and that is there. If that is the case, it means this side will go with this side, right? Right. And then this side over there will go with this side. So let's see. And then this also means that side, the 8 would also go with this one. On the other triangle. Now let's see what happens here. So we're saying this is there, that is that. So we've got 10 over 15. This one gives us a 2 over 3. Oh, this gives us a 2 over 3. Let's see if that is consistently the case. What happens when we take that 12 and divide by 18? We still get a 2 over 3. What happens when we take the 8 over 12? Voila! So this works. So this means this is all correct. So sometimes it can overwhelm you. So all we can say here is that in triangle BCA and triangle CDB, what are we going to say? Now we found the magic. So we can see that we have to be smart about things, unfortunately, otherwise it doesn't work. We can safely say here that AC from the other one over, what did we say is going to be BD? It is going to be equal to 10 divided by 15, which is going to be equal to, maybe let's just make this one as, okay, it's fine. So this is basically 2 over 3, because the common factor there is 5. Right, we can say also, what do we see? We can see that essentially BC on that other one over, this one will go with CD, is going to be 12 over 18. This is going to be the common factor, there is 6, so it's 2 over 3. And then likewise, we are going to suggest that AB over BC on the other one is going to be 8 over 12. The common factor there is 4, so this is 2 over 3. We can say, therefore, we can conclude that AC over BD is equal to BC over CD is equal to AB over BC, ne? Because each is equal to 2 over 3. We can make a conclusion, therefore triangle BCA is similar to triangle CDB. Okay. Again, what are we going to say? We can just say the sides are in the same proportion. I have not found a better way to put this one when you've got sides. So we've proven that the sides are in the same proportion, so they should be similar. So this is it, guys. So we're scoring 4 marks, you know. Yeah. So this is important, and this is very important to showcase. Now, I'm thinking, where is the 3rd mark? I mean, where are the other 2 marks, guys? Yeah, ne? So maybe we can say this can give us 2 marks as a whole. All of it, because what can you say? What can you say? So this is 9.2. Says, hence prove that AB is parallel to CD. Yeah, that's easy, man. That's easy. So this one is pretty easy. What can we say to suggest that? I'm trying to think of a way now. So the way we put it, so we can simply say angle, say for example from the other one, angle ABC is equal to angle BCD. Why? These are the corresponding angles in similar triangles in 9.2. Okay. So obviously once we prove the sides are in the same proportion, it simply says these angles, I don't know, these are the corresponding sides, because look at this. What is the side opposite B? It is 10, and then the corresponding side on the other one is 15. So can you see? So if this is the case, I don't know, man, how to put this. We can say sides. I'm thinking now, what could be the best reason? The side opposite angle B in this triangle, and the side opposite that other angle is that. So if those sides are in proportion, it means those angles are equal. Maybe we can even write a very comprehensive reason and say, since we could tell that AC over BD is, but what do we say? That must be yek. Masingabe sithethe into ezininzi so zesixoxe ne. We don't want to lie, so these are the corresponding angles in similar triangles that we proved above, and we're trying to suggest that. So this means AB is parallel to CD. What is this? This is the converse of alternate angles. Okay, because if we prove alternate angles to be equal, it means then the sides are parallel. Or normally we were first told that the lines are parallel, then alternate angles are equal. So how you put this, I don't know, guys, but as long as it will make mathematical sense, this is important. So this statement is important, and that statement is important. So that was a bit of a cumbersome thing. So let's see, 9.3, can we do it here? Calculate the length of CE. Easy. Where is CE? So this is this little length here. Okay, yeah, that is a very technical calculation now. Okay, all right, okay. So this question is silly. 4 marks means most likely 2 steps. So for us to be able to do that, we need to focus on some 2 triangles, which we need to be smart about it. Yo guys, this video is gonna be longer than I wanted. Yo. I should be finished now and I'm still doing it. Okay, CE. CE. Here. I'm trying to figure out, folks, what are we supposed to do here? Because it's not easy, eh? It's not easy. I'm trying to figure what should we do, but we need to prove similarity of certain triangles, né? So we just proved that this is parallel to that. Does it help us? Maybe. So yeah. I need to be smart about my business, guys, because if I'm not smart, it's going to hurt. And when it hurts, it's going to really hit very hard. Ne? So, I'm trying to think, boys and girls, what are we supposed to do? Because what I was thinking about, it's this triangle here and that triangle there. Right? Because what I can do, I can safely say this angle right here in this other triangle is equal to that angle, né? Because, so let's see those triangles that are highlighted, right? Because we proved those parallel lines, so these become alternate angles, né? Great. But we also know that this angle over here is equal to that angle here. Those are vertically opposite angles. So once we prove 2 sets of angles to be equal, the remainder will be equal. But at the same time, we've already proven that C is equal to B above. So those triangles are similar. So we can use those triangles. You can say here in triangle AEB and triangle CED. Okay, how I name them is not something I really care about. I just want to go for it. So all I know is that angle A in this other triangle is going to be equal to angle D in that other triangle, right? These are alternate angles with AB parallel to CD. Always state that. That's number 1. Also, we know without a shadow of a doubt that angle, maybe let's put CE, wait, it's AEB is going to be equal to CED. Ne? These are vertically opposite angles. Vertically opposite angles are always equal. We can say this implies that. We don't even have to say implies. We just say it and say here. Likewise, we know that angle A, I don't know now, I'm losing my focus, ABE is going to be equal to angle ECD. That is proved above. Because that's what we said. So what can we say? We actually used a different notation, right? We said ABC. Maybe let's use that same notation. Say ABC instead, because it's still the same angle. And BCD. Either way, those are angles in those triangles. Still the same thing. So we can say, therefore, triangle AEB is similar to triangle CED. This is because of them being equiangular. Okay, now from here we can take something out of it. So this means we can say then, what can we say? We want CE. Now CE belongs in which triangle? In this other triangle. So we can say CE over CE is basically the side opposite which angle? It's opposite this angle, right? Because if you read like that, CE is opposite angle D. Now this angle D is equal to that angle A there. The side opposite that angle is going to be EB. Okay, it's going to be EB. Now I'm feeling like I'm not happy with EB. EB is not going to be very helpful, is it? So we need to find a way of being smart. Now we're going to try and be smart about our business and say EC over, let's use the side, over CD. We can do that. Same triangle. We take that side over that. It should be the same as we're running into the same problems now. Having proven similarities, we have a situation now. Anyway, guys, I think I need to be very good about this thing. So let's just do it the way we want it. It's going to be silly anyway. So this is going to be over EB. Or since we started with the other one, but it doesn't really matter where we start. So the side opposite, that is EB. Let's just leave it at that. Then we take the sides that we want. So it's going to be CD on the other one. This is opposite that. It's going to be over AB. So what is the reason? These are the proportional sides in similar triangles in... Let's leave this one. Proportional sides in similar triangles. This implies that EC is going to be equal to, just cross multiply that thing without causing us any problems, over AB times EB. Yeah. Then what do we know, guys? We have a but. What is that? We know that EB is basically equal to BC minus CE. Yeah. Because EB, we take BC and we subtract CE. And that is just there on the diagram. You can just say C sketch if someone is asking questions, because that is what we need to do. So we can say therefore EB is equal to 12 minus CE, which is what we want. Now what do we do from here? We can say this implies what? That EC is equal to CD over AB into 12 minus CE. Yo, anzange ndayibona into enje. Yenye indaba. So this implies that EC is equal to CD is 18 over AB, which is 8, into 12 minus CE. So the rest is just algebra, guys. So between 18 and that, this is basically, let's see, 18 over 8. This is 9 over 4, times 12. It's 27. So I've got 27 minus 18 over 8 CE. So that is it. And then we take this one to the other side. This implies now, now we take that, it's a like term. So we're going to have 1 plus 18 over 8. So this gives us a 13 over 4 CE equals 27. Therefore CE is going to be that 27 divided by 13 over 4. So this one gives us a 108 over 13, which when we round off is going to be 8.31 centimeters to 2 decimal places. Okay, again, this was one of those questions where they're hiding the fact that you're working hard. Ebafethu. Lapha nengixolela siyangena kwi-4 hours ngoku. Hey, yabona ke. Wasisikhe senza neblunder somewhere. So for me, this is how I see it, guys. So whatever we're doing, we are just doing it, okay? Unless there's another way of doing this, which is, we can take the proportional sides without trying to use these similarities, because sometimes you wonder if that can work. We just choose sides that we can use, but I don't think it would make any sense, would it? Let me just test it. Since now we have a bit of time, we have lost anyway this time, so I'm not going to bother ourselves. So let's see. Which side has a BC? Because BC is what we need here. There is BC. Then do we have there? So we know from above that BC over CD is equal to AB over BC. We can do that from this one here. This is stealing it from here. Or we can do the other one. It doesn't really matter. We can do any other one of the two. So let's see. Could we use that? Maybe. But now what we want here is to express BC as, so this is going to be BC squared. Okay, let's see. This is BC squared equals, when we cross multiply, CD times AB. But now we've got a but. We know that but BC is basically made by CE or EC plus EB. That is obvious. So what do we want? We essentially want to express that as such. Yeah, this one is going to be a bit of a flip-flop, I'm telling you. And then what we want to do there is to, well, I don't like this one with squares. It's terrifying me already. Let's avoid squares. It's already terrifying me. So let's take the other one and say BC over CD is the same as AC over BD. Let's try this one. Now, what do we know? we know that we want to use side BC to our advantage. BC is basically CE plus EB. Ne? That is the one. That is BC over CD is equal to AC over BD. Ne? Nice and easy. And then now, what do we know? We need to eliminate this guy. This guy is essentially BC minus CE. So this is a bit of a situation. CE plus, instead of this one, we're going to write BC minus CE as well. Okay. And it doesn't work, you see, because now these ones will cancel. It won't work. So I don't think, guys, we need to waste our time on this one. Let's just leave it. But think about it. I don't know. It's possible. So for me, it doesn't matter how long something is, as long as it makes sense. So essentially, this one is important. That one is important. Ne? It is very important. And from proving that similarity, stating this is important. That is the second mark. And essentially, this substitution here is important. It's very difficult. And then the answer. Correct to 2 decimal places. Again, the last question, you can see that it was meant to cause a few scares in your mind. So let's move on, guys. Last question. Let's enjoy this one and finish this 4 hours, which we could not avoid. So I can tell most probably 80% of students who sat for this paper didn't finish, okay? It was long, I can tell you. Anyway, in the diagram, O is the center of the circle. Is the center of the circle PSRT. So what does that mean? It means this PSR T is a cyclic quad. And why is it so? Because all the vertices are at circumference. So they're just trying to say this is a cyclic quad. So these are implications. Please, guys, read this with care. Now, TR produced, again, once you're saying something is produced, you're trying to suggest that that is a straight line. So TR produced basically we're suggesting that is a straight line. Now this means essentially, before we can even go anywhere, this would mean this angle should be equal to that angle. Why? That's an exterior angle of a cyclic quad, because if you produce one side, you're forming an exterior angle. So that is the story that we get here. So not a problem. Now TR produced intersects SV produced again. SV at V. Okay, we can see that. Now ST bisects. Once you hear that, it bisects PTR. So it means this portion here. This portion here is equal to that portion. So meaning those angles are equal. So those dots are saying those two angles are equal. So we are good. We have information. And then we're told and ST is equal to SV. And then that one is indicated. If that is the case, this suggests that this angle V is also equal to T2. Why? Because this is an isosceles triangle now. Those become the base angles, okay? TOP, OS, and SR are joined. We are fine with that. So what can we do with this? Now that we started interpreting it a bit, what else can we say? We know that these are ready. If they are ready, if that angle is that angle, So here's another angle. That angle is also equal to that because that becomes an isosceles triangle. Indaba ezimnandi ne? Yes. Is there more we can do? Since this line is from circumference through the center to circumference, and it's a straight line because they said TOP. Once they call it out like that, it means it's a straight line. So that TOP there, that top there, that top is a line. So it's a diameter. So we already know that a diameter always subtends a right angle at circumference. So there's a lot of things we can say, but sometimes it gets a bit overwhelming. And at times you want to stop. Okay? So at times you just want to stop and start putting it to the test. So let's go 10.1. What do we want? Determine with reasons the size of PST. Can you see? Size of PST. That means in degrees. PST. Can you see? 90 degrees. It's done. So we know that angle PST is going to be equal to 90 degrees. The reason, this is the angle at semicircle. Or you can say it's an angle subtended by the diameter POT, because they told us that is a straight line. Once they say you're joining something, that joining says it's a straight line there. Nah, maybe. Yeah, whatever, man. It becomes a chord in the circle. Maybe they should have said chords are drawn, and maybe it would make sense, but that's the implication. So you're getting a mark for the statement and for the reason. So that's easy. 10.2. It says determine the size of S4. Again, that means in degrees. So this is the guy we are looking for, S4. How will we find the size of S4? Now that is a tricky question. Ne? And you can see here 5 marks. It means gymnastics are going to be very critical here. But what I can already tell you is that we're going to have to use angle R2, because we know that angle R2 is linked to angle P. This is how we can cross over to this one. Okay. All right, okay. Now, what can we do also? Well, we know that if we focus on this triangle, so if we focus on that triangle, how can we express angle P? Angle P would essentially be 90 degrees minus that angle T2. Right. So this is what we need to work out this business. But all we know that is that this angle V here is essentially equal to angle T2. So that is what we can use here to work our magic. You get me? So we can say here, look, angle P is equal to 90 degrees minus angle T1. Okay? How do we know that? We know this from the sum of 3 angles of triangle PST. You don't want to waste time. You want to jump in. We have to say though, but okay, we know also that, look, angle R2 is equal to angle P, right? Why? This is an exterior angle of cyclic quad PSRT. That is obvious. You can see the vertices at circumference. So can you see we moved from that triangle into this one? So now we are sorted. This means R2 is basically also 90 degrees minus T1. Easy. So we are sorted. And this looks like 90 degrees, ne? So that means it's probably 90 degrees. We can say then, what can we say? We know that then in triangle, say RSV. What can we say in that triangle? We know for a fact now that angle V, it's important to state this one, angle V is equal to angle T2. Right. Why is that? This is because of angles opposite equal sides in triangle. We're using another triangle to prove another one. In triangle VST, given that ST was equal to SV. We're trying to prove this, you see. Yes, I don't know, but this is going to work. We can say therefore angle V is going to be equal to angle T1. Right. Why are we saying that? Because we know that T1 is equal to T2. That was given. This was given in the statement that says ST bisects TR. Maybe we can say that. We can say ST bisects PTR. Oh, we're writing an essay here. This is a math essay. Don't take it lightly. But now what are we trying to suggest? We are trying to suggest that, look, we can easily say angle S4 plus angle V plus angle R2. This is equal to 180 degrees. Again, this is sum of three angles of a triangle. But now we stated that our triangle of interest is RSV. If eventually. So this implies what? That S4 plus V1 we substitute with angle T1 plus angle R2. R2 we found out above, it's 90 degrees minus T1 equals 180 degrees. Can you see? T1 and T1 are like terms and they simply cancel. Okay. So this implies, in fact, we can make a conclusion here. There's no need to delay that. Angle S4 is going to be equal to 180 degrees minus 90 degrees, which is 90 degrees. Well, the look matched the findings, is it not so? So that was a nice question. Again, I suppose this is one of those higher grade questions because nobody tells you. This is where you're going to have to start. They're not even giving you leading questions. They want you to find your path on your own. So essentially, this question, this was a very important statement. 1 mark, that's number 1. And then, essentially, this statement is important. That is the 2nd mark. This is a means to an end. We're not going to worry about it. And then the next statement was to get here. That is the 3rd mark, essentially. And then substitutions and answer. So 5 marks, nice and easy. We are where we want to be, okay? So 10.3. It says prove that triangle TSO. Now where's that? TSO. Okay, so now we're looking at this triangle. Maybe let's highlight it like this. TSO is this one. So there is TSO. So this says, prove that that triangle is similar to TVS. TVS. So this is this triangle we're talking about. Now maybe let's give it a nice yellow color. Okay, so there's the yellow color. So we are comparing those two triangles. Ne? So how are they similar? Well, we need to just prove two sets. Okay, and that is done. Can you see? We know that this one is equal to that, it was given, and then that one is equal to that, we proved it, and this one is equal to that, those are the radii. So this is done, Bafwet. This is done. So we can just simply go for it and say in triangle TSO and triangle TVS. What do we see there? Well, we can see that angle T1 is equal to angle T2. That was given. It was given. Indirectly, of course, but we don't want to waste our time here. And then we know that, also, what did we find? We knew that angle S2 was also equal to angle T1, right? What is that? These are angles opposite equal sides in triangle TSO. Why? Because OT is equal to yeah, this one is a bit cumbersome, OS, which is the radii, the radii. Sometimes you can be creative, man, come up with ways of saying things. So if this is the case, what does that mean? We also know that T1, so here we can say, but what do we know? We know that angle T2 is equal to angle V what? Angle V. Hey, not according to the but did we link anything? Yeah, V and T1. We linked V and T1. From above. Maybe let's say this one, T1 is equal to V. So from this statement right there, V1 is equal to T. This was proved above. We can say, therefore, what are we interested in is to take S2 and equate it to V. Now we can say H is equal to angle T1. Can you see? This was a bit of a cumbersome thing. And this literally says, it literally says angle O1 should be equal to angle S4 plus S3 as a whole, because that would be the other angle. Again, we can say this is the remaining angles. Okay. So therefore we can say triangle TSO, triangle TSO is similar to triangle TVS. Again, they are equiangular. Okay, this one looked a bit simple, but it was a silly question. It's not easy, it's not difficult, but the links sometimes are a bit cumbersome. You get me? Now let's look at this one. 3 marks. think this one is important and that one is important. And essentially, yeah, man, maybe this one was an important one because the ready we didn't mention them, so we accounted for them. The rest was pretty straightforward, so 3 marks. Now let's do 10.4. Now this is going to always cause trouble. Now for me, how do you start a question like this? Inspect these things. Where is VS? VS is this side, right? So meaning it belongs in this triangle that we worked with at some point, or this yellow triangle. But now we're saying squared. If this is squared, what does that mean? It's either we used Pythagoras, because this is a right-angled triangle, right? We proved it now that that S4 was 90 degrees from above. So we either used Pythagoras, or we're going to use similarity. So you see, you're just brainstorming what you're going to use. Is it Pythagoras or is it similarity? If it was Pythagoras, we would expect to have some signs, a plus or a minus, meaning we needed signs between some terms. But if we used similarities, usually we use products because those are proportions. The opposite of division is multiplication. So most likely we're going to need to use similarity. Because if we use Pythagoras, we may not succeed. Because we will end up with signs, things we don't need. Unless if we use signs, things are going to eliminate. That is possible. But anyway, let's have a look at it. Where is PT? PT is that side. So PT is this side. So PT is that side. Let's just put a correct there, or a tick. There's PT. So how is PT related to this business? Yay. Ingathi sisengxakini ke ngoku. Sendiyayibona isekude. And TV. Where is TV? TV is this whole side. Yeah, ne. Hey, isn't as dibananga ke ngoku? Ingxaki zethu zininzi. Sendiyayibona ke ngoku le nto. So guys, this last question is killing us. So this is a higher grade question, I can tell you. It's one of those questions. Again, yeah, they were killing you guys. So what are we going to do here? Which triangles are we working with? We are either working with this triangle here, ne, and this triangle here. Because what do we have? We've got, yeah, but this is gonna be dangerous. If we say this and that, the problem is TV. Our problem is TV, man. Why is TV showing up there? Why is that? Okay, so we can see here there's a 2. Oh, okay, I forgot. There is a 2 there. There is a 2 times SV. So if there's a 2 times SV, it means we will have a lot of things to consider. But in any case, did you go over to this question paper? Was dangerous. Even my technique is trying to not work. Maye babo. But if we've got 2 SV squared, it means something is doubled here. Ne? Something is doubled. And I can tell you, something is coming from here. We can't prove that similarity if it is not going to help us. So that something needs to come from there, because this 2 is trying to indicate we are using a side OT, which is half something. A 2 is going to come up from there. So for me, we have to try and use these 2 triangles again. So what we can say there is that, well, OT, because this can give us PT, this OT. So let's look at that and say OT over, now remember OT is opposite S2 in these 2 triangles that we proved. And that angle is equal to yet another angle. We can decide what we want. So OT is opposite S2, but we said S2 is equal to V. The side is ST there. The side is ST, but now we don't have ST here. So we're not going to use that. We're going to use this one, T2, which is going to give us SV. It's going to be equal to. But maybe we're not going to be able to run away, but I'm going to change the angle and say, yeah, TS comes up even if we try to run away. Even if we try to run away, TS is coming up. But anyway, let's not use TS. Let's use, TS is going to come, because for us to have that TV, we need to use ST. So let's just say ST over. Now this is that angle, O1 equals that S3 and 4. The side opposite it is TV. Okay, so let's see. This is now sides, proportional sides. In similar triangles in 10.3. So just give us that proof and be exact. But now, what do we want to do before to? Well. We know that we've got a lot of things here that we need to eliminate. But we've got TV here, which is what we want. So let's see. This implies, let's just cross multiply there. We're going to have here SV times ST is equal to OT times TV. Right? Right. Now what do we know? We know that OT is equal to half PT. Why? Because this is now POT is the radius. I mean, we can say OT is the radius. The radius, we can just say radius is equal to half the diameter. That is essentially the reason. I mean, that is what we can say. So now this implies that SV times ST is equal to now a half of PT times TV. Can you see? Kitchen. We've got those two guys. That and that are coming up. Because these two we can cross multiply there. Because I mean this is over 1. Is it not? And this is over 1. I mean over 2 together. So when you cross multiply here, therefore we know that 2 times SV times ST is equal to PT times TV. Yeah, one. So now our business now, okay, they used VS instead of SV. SS. Okay, I mean this thing is the same thing, but let's adjust it. VS. Okay. So we've got a portion of the left hand side and we've got ST, but now our problem is ST. ST needs to go. So we've got this friend. How do we get rid of ST? Buffer weight. Yeah. Did I do everything correct though? Looks like it. So how do we get rid of ST? Yeah, this is irritating now. ST is basically common to those triangles. Yeah, when yes, we know that ST is equal to SV. That is given by that. Yes. Yeah, I think my brain is losing its shine now. We know that, however, we know that, however, we also know that ST is equal to SV. Or they said VS. Scotlandina is VS. That was given. Okay. Therefore, maybe let's say this is an implication. Therefore, 2 times VS. Instead of ST, we're going to write VS is equal to PT times TV. Okay. Yeah, we can do this conclusion twice, man. Anyway, we can say it implies, and therefore 2 VS times VS is VS squared is equal to PT times TV. Okay. Now the labeling nice. This one was suplexity. As much as I'm not gonna say that B word that Brock Lesnar uses, suplexity word, it's suplexity boys and girls. So I'm gonna say B and S. Oh, BS. All right. Yeah. Hey, bafowethu. Kuyafika. But can you see? Sometimes you get clues. As I said, you start thinking, what am I supposed to use there? And then you just go ahead and explore your options. So basically, this is very important, because if you don't use that, we are not going to get anywhere. And essentially, this substitution here is important. All right. Okay. All right. And this little business right there is important. And then this substitution again. I don't know, guys, but yeah, this thing is crazy, you know. This thing is crazy. Maybe I would essentially give you this mark here, because it's not so obvious, you know. To get that half is important, I suppose. This is how these 4 marks come about, because the rest is just what you would do to get to the marks. So yeah, I being a young I'm cry nicely. There was a bit of, you know, tears and joy. And I'm sorry, guys, I took longer than I planned to. And I made some mistake of pausing the video while I'm working. So if you missed that portion, you should be fine. But yeah, that is essentially how you would go about this video. Remember, guys, this was for revision. It's not about time, but I'm just trying to show you how you can do these things properly while you actually save time. Again, you can see it's not always going to work. You have to certainly strategize areas where you can score marks and forget about areas that are going to terrorize you. But in a nutshell, you have all that you need at your disposal. I have my channel right here. You've got these videos. If you have any questions about some of the maneuvers I used here, you ask about it, or if you have any other suggestions, you go and suggest them on the comment section. Otherwise, I leave this to you guys. My next video is going to be the paper 2 from KZN. I'm gonna look for that paper and work on it. It was by request, so I always respect as many requests as possible, even though I cannot do all of them, but I will try, because as many as they are, sometimes there are certain important areas that need to be clarified. Hey guys, let's not talk too much. Have a goodbye. I will see you on the next video.